main goal idea. Additionally, this conference will also facilitate the pose and share ideas. The conference to bridge the research working in academia, their professional research, presentation, Industry 4.0, and practice for contributing better opportunities in Industry 4.0. You will get ample opportunity to when you will knowing the network outside of this conference. I hope that you will enjoy some of the attractions found in and around beautiful exposure and global opportunities to all. Thank you very much.
Also like to inform you all joining us on Zoom. We have Mr. Collaborator. Sir and ma'am. And now it gives me immense pleasure working as director RIT Roorkee, specialized in MTech and PhD in computer science. He has a distinction of working as a research scholar under the guidance of internationally acclaimed Indian Institute of Technology. 13 international and 9 national. Apart from his administrative science, Abhidan is continually contributing to academies, wherein 8 PhD research scholars are researching under him in Uttarakhand Technical University. He has attended many international approach is truly adaptable. A couple of years to work on the project won the Open Hearted Appreciation in the national level competition, and he was bestowed with the trophy of Best Mentor Award for the innovative project directly by Texas Instrument. Then we have a huge round of applause for our own director, Dr. Faraj Jain. And I would request Dr. Jain to kindly come up on the stage and say a few words about the international conference.
Very good morning. I want to extend a hot welcome to all the professors, students, researchers, and those with the ICFMRS-2022 ERP. Our keynote speaker, In the list of invited speaker and keynote speaker have added as part to the virtual international conference. Thank you. Thank you very much.
Thank you very much, Dr. Jain. And now I will request Mr. Gaurav Chaturvedi, Dr. Gaurav Chaturvedi, to kindly come up on the stage. Before that, I would just like to introduce you to the audience. Dr. Chaturvedi is the Dean Academics of RIT, specialized in computer science and engineering. Professor Gaurav Chaturvedi has filed an Indian patent insurance by IP India. It is a matter of great pride for all of us. He has the skill in these skills: artificial intelligence and machine learning, cloud services, web development, full stack. Many papers have been published in the international and national journals. With that note, I would now invite Dr. Chaturvedi on the stage to kindly say a few words.
So first, good morning to all national and international colleagues and distinguished guests. I would like to welcome all the academicians, researchers, and scholars in this 2 days conference who will develop basically the cutting edge knowledge and innovation for future schools. The crux of this conference is basically the use of digital technologies like AI, augmented reality, virtual reality. Basically, these type of technologies being increasingly adopted after the outbreak of COVID-19 pandemic. As you know that information manipulation is rising these days with the help of social media and internet. While the general public is less than equipped with the digital skills, media literacy to deal with this kind of phenomena, it is very much difficult to determine who has real control over the social media and how the information is going to be presented. Okay, now it's fine. Okay, so the use of AI and data science basically will emerge all these type of technology in this conference, and we hope in 2 days conference would help students to expand their mental horizon. And I am honored to welcome you once again to all the dignitaries and wish that all of us participating will be more hopeful and enriched at the end of this conference. So thank you very much.
Thank you. Thank you, Dr. Chaturvedi. And now, ladies and gentlemen, I would like to see if you are still connected through Zoom. Is it working? All right, so just trying to confirm, Dr. Krishnan and Ms. Deshpande, can you hear me? Am I audible to you?
Dr. Krishnan and
Yes, I
Ms.
can hear
Deshpande,
you.
just wanted
Yes,
to
yes.
confirm.
Good morning. Good morning. Very good morning.
Good
I'm
morning. Am I
Gopal.
audible to you?
Yes, yes, sir.
All right, great.
We'd just like to inform everyone, to the audience here, that we have two of our guest speakers have joined through Zoom. We have Dr. Gopal Krishnan, he's Scientist D, National Institute of Hydrology, Roorkee. And we have Ms. Chinmoy S. Deshpande, Senior Supply Chain Transformation Leader, IBM, North Carolina, United States of America. We welcome you, to both of you, to this international conference. I hope I am audible to you.
Yes, yes, please.
All right, great. Just to introduce you all to Dr. Gopal. Mr. Siv Kumar Sajjar, am I audible to you? Can you hear me?
Yes, sir. Good morning. Is it
Good morning, sir.
audible, sir?
Yes, we can hear you. Am I audible to you?
Yes, now you're audible, sir.
All right, great. We welcome you to this conference, sir. I hope you're doing good there.
Yes, sir.
All right.
So yes, very good morning to distinguished guests, eminent scholars, delegates, committee members, participants, and students. On behalf of IFERP, it is a great pleasure indeed for me to welcome of all delegates, speakers, session chairs, committee members, academicians, young researchers, participants, and students who joined here to share their knowledge and vast experience for impressive and prestigious international conference on future road of multidisciplinary stream, organized by Roorkee Institute of Technology and IFERP. I would like to thank you for giving me this opportunity to share with you my perspective about this conference. This conference will focus on impact of transition to fourth industrial revolution on infrastructure, ecosystem, efficiency, and competitiveness of industrial operation and impact of robotics, AR, IoT, and artificial intelligence on value chain support and optimization, and then operational changes on industries with emerging into smart operation in terms of monitoring and controlling data will be available. The way that modern people live and work is changing as a result of disruptive technologies and trends, including the IoT, robotics, virtual reality, and artificial intelligence. This is known as the fourth industrial revolutionary. Industrial 4.0 referred to the incorporation of these technology into production process. The World Economic Forum founder and executive chairman Klaus Schwab invented the term Fourth Industrial Revolution in 2016. Nanotechnology, biotechnology, novel material, and advanced digital production technologies are just a few examples of growing technical fields that have come together and complement each other to form this field. This large category, which also includes 3D printing, human machine interface, and artificial intelligence, is already changing the face of industrial world. The notion of Industrial 4.0 offered known as a smart factory, a factory that continues to adopt and optimize its own operation based on what it learned as it work result on integrating of ADP technology into industrial production process. The innovative way in which hardware, software, and connectivity are recognized and integrated to achieve ever more ambitious goals. The gathering and analysis of enormous amount of data and seamless interaction between smart machine and blending of physical and virtual dimension of production are what truly distinguish Industrial 4.0 technology. For instance, sensor may pick up on certain activities, process length, on environmental factor like temperature, enabling independent self-artificial intelligence to minimize downtime and free up resources. These data points may also be fed through the system real time and optimize the adapt later price of production process. The aim of this conference is to provide multidisciplinary platform for leading researchers, young engineers, academician industries, and practitioners working in India and rest of the world to of my multidisciplinary streaming. The conference will feature traditional paper presentation and keynote speech by eminent speakers who will focus on state of art development in the field of engineering research and innovation. The scope of the conference is to provide a common platform where researchers, engineers, academicians, industrialists, and practitioners and sharing their research and innovation and deliberate upon futuristic research along with the major bottlenecks. There has always been a gap between student, academician, universities, and research communities and industries who can make effective use of engineering research and technology and those who cannot. IFERP is on the way to bridge the gap between student, academician, institutes, and industries. The mission of IFERP is to serve as an accelerant of knowledge sharing, community development, and global technology innovation. IFERP objective is to prepare the global technology innovation through the funding, fostering, and furthering of a culture of steadfast research and unthird professional and academic collaboration. IFERP initiated several initiatives: IFERP Academy, Youth Empowerment Program, Career and Skill Development Program, Industrial and Institute Interaction, Faculty Development Program, Research Assistance and Guidance for the welfare of youth, academician, and society. IFERP Youth Development Empowerment Program are behavioral, structural, and cultural processes that provide young people the capacity, authority, and power to take charge of their own lives and the lives of others, both youths and adults, and to make the decisions and bring about changes. We define empowerment generally as giving the poor more freedom of choice and control over their own lives. This is our opinion involve having authority over resources and choices. The foundation of IFERP Youth Empowerment Program and Skill Development Program is the belief that young people are the best resource for fostering growth and that they are change agents of who can comfort their own difficulties and find solution to their own issues. IFERP holds that all youth, regardless of their cultural and socio-economic background, are capable of giving other needs and want to respect that deserve and addressing them. As an organization, we collaborate with a wide range of top experts, academic researchers, comprehensive science and technology universities, research agencies, and companies. We consistently work to promote quality in higher education, training, research, and innovation by influencing public opinion on their key challenges by assisting in the creation of open knowledge society and by significantly advancing the science, business, the economy and society through our numerous initiatives. While concluding, I would like to welcome all the conference participants who are awaiting to share their knowledge and experience and to explore better way of education our future leaders. I take this opportunity to welcome each and everyone who express our gratitude in your agreeing to participating in this conference. To put a conference together is a magnitude, is not a small task to the tent. I would like to express my sincere gratitude to our coordinators, organizing committee members, advisory committee members, and session chairs. I welcome once again to entire IFERP group and Roorkee Institute of Technology for this Indian International Conference of Future Road of Multidisciplinary Streaming. Thank you.
Okay, thank you, sir. Thank you for your wonderful speech. Yes. On.
सर इधर आइए. बच्चे बैठ जाओ प्लीज.
Hello. Am I audible?
Yes, sir, you are audible.
So I should start now?
Yes, sir.
Okay. So very good morning to all. You can see me, I am at Kashmir. So here temperature is -4 degrees centigrade. So I will be mainly talking on the water sector only. So the topic of my talk will be environmental research in water resources management. So as MD sir told that there are various tools and techniques which have been developed in the science for the progress of science. So I am presenting one of the such technique or tool or you can say tool in the water sector. So first, I am from the National Institute of Hydrology, which is in the same town where RIT is situated. It is just 4 to 5 kilometers away from the RIT. And first of all, I will introduce my institute to you. So National Institute of Hydrology, you can say, it is an autonomous institute under Ministry of Water Resources, River Development and Ganga Rejuvenation. Now the name is changed. Now it's Ministry of Jal Shakti, and has been functioning as a research institute in the area of hydrology and water resources in the country. So, and main objectives of the institute are to undertake support, promote, and coordinate systematic and scientific research work in all aspects of the hydrology and water resources, and study scenario of water resource availability under varying hydrological, climatic, socio-cultural conditions through modeling techniques, and assess impact of climate change on water resources, suggest measures for mitigation, adaptation, and resilience, propagate applications of emerging techniques for water resource development and management, provide cost-effective R&D solutions to need-based water-related problems, and empower community through capacity building and awareness on water resource development. So our institute carry out back-to-back training programs in water sector where the various new techniques have been developed, and even the various models or decision support systems, those has been taught to all the trainees at our institutes. And we also concern of the resolution of the pressing societal issues. Those are like your water quantity and quality, including floods, droughts, groundwater, sedimentation, salinization, pollution, and the climate change. So first of all, what the contents of my talk will be like: introduction to the hydrological cycle, water distribution and need for using the tracer technique, environmental tracers, introduction, types, use of isotopes in water resource management, recharge estimations, how we estimate the recharge, and then some case studies. So first of all, I give you hydrological cycle. In hydrological cycle, the sun is the main driver. From where the oceans, water gets evaporated due to the heat of sun, and that evaporated water gets condensed. And this, all of you may be knowing, this condensed water, this condensation is in the form of clouds. When it moves to the continental areas, wherever it moves, it causes a rainfall or precipitation. So here you can see it is moving the continental areas, and the rainfall is again. As it comes down to the surface of Earth, it either goes as a river or runoff again to ocean, or it goes down. It infiltrates down into the soil moisture, and then ultimately it forms the groundwater. The process of percolation. So groundwater is also a dynamic. It is not a static resource. It is invisible, slow, but it is moving. So, and it is also a distributed resource. I think you all may be knowing this. And if you come to the hydrological, how water is distributed, here you can say, if you see the total 100% of water on our Earth, 97.4% of this water is saline. Means it is not usable by the human beings. Only 2.6%, that is a fresh water, is available. It is usable. So from this 6%, you can see 1.74% is your ice and glacier, 0.76% is your groundwater. This is your violet. And active water is 0.1%. So what is this active water? This active water is your lakes and wetlands, rivers, soil moisture, atmosphere, and other living things in biological water. So we also contains the human water. So as you know, our body is made up of 70-80% of the water. So, but if you see the total estimated water on our Earth, it is 1.39 billion cubic kilometer, but human consumes only 0.003% of it. So if you see the global water use, how the globally water being used. So here you can see in the world, it is the water used in world. So Asia is very nearing in the world. It is at the top of all the continents in the world, where you can see the largest. It is the largest water user. So here you can see by region in cubic water. This has been presented here. So you can see here, this is your Argentina, and they are using less. Then your Africa, South America, and this is the water consumption. If you see the sector-wise water use, there are various sectors. These sectors are your agriculture, which is the highest user of this water. And then the industry after agriculture comes the industry. Then your municipal supply. Municipal supply is also called the domestic use, domestic sector. So third one is your domestic sector, and last your reservoirs. What is the water that is stored in the reservoir? So if you see the sector-wise percent use, you can see here agriculture 70% and domestic only 8%, and industry is using the 22% of this water. So water use, if you see the economic growth in the USA, they are using it 41% for the farming. So there is no doubt they are using the more efficient farming systems, and they are maintaining this water use efficiency. And in power plant, they are using this more of this water, about 38%, and industry 11%, and public 10%. But in India, farming 85%, because the agricultural use is very high, and even our irrigation methods are not that sound. Generally, we go for the flood irrigations. In flood irrigations, what happens? Either the water will go as a runoff or it will evaporate. So there are water losses are very high in the flood irrigation. So there are some new techniques have been developed, like your drip irrigation, sprinkler irrigation, to increase the water use efficiency. So here in power sector it is only 2%, where it was in USA it was 38%. So this is the water use in the world. And if we come to the domestic or municipal water use, so here you can see how the water is being distributed here. You can see most of the water is used for the shower or bath purposes, and it is toilets cleaning and all those things, then sanitary purposes, and kitchen cleaning, and then you can see laundry, outdoor, and miscellaneous. So you can see this is how the water use is our houses. And in some then water stress. So in 1995, you can see here, this was in India, which was a 40% shade. So, but in 2025, it will be like this. So it is where there will be the water withdrawal is very high, and the water we have been going to the water stress. In 1947, there was abundance of water in our country, but that has been gone down now, and the water availability. But we are moving from water scarce. When for a year, 1,000 cubic meter water is available. It is called the water scarce. And water stress, when it is the per capita availability is less than your 1,700. So we are moving from water stress to the water scarce. So this was our and then the water general facts. Most of you must be knowing this. 2 billion people have no access to clean drinking water, and 2.9 billion have no access to sanitation. They have access to the drinking water, less than 9 billion, but don't have any access to sanitation. By 2025, 40% of the world population, or about 3 billion people, so 1 billion will be added to this, will live in the countries where it is difficult or impossible to get enough water to satisfy basic needs. 80% of all illness and death in developing world due to the contaminated water. So a child dies every 8 seconds from the drinking contaminated water. So you can see these are the general facts of the water. And if you see the India's land resources, our geographical area is 329 million hectare, and non-cultivated area is 7%, and wasteland is 20%, and forested area is 23%. So cultivated area here it is 47%. And irrigated area from this is 37%. From this is irrigated area, and rest is dependent on your rainfall. Whenever there will be rain, there will be availability of water. So if we come the India in world, India's land resources are 2.4% of the world, and India's freshwater resources 4% of the world. India's population is 18% of the world. So you can see the water demand is very high, and the India's cattle population is 8. In addition to that, water demand is also from the cattle population. 48% is demanding water, and the available resources are only 4% of the world. So you can see the demand side is more on the heavier on the availability of water. So then if you see the global and regional trends of the surface and groundwater, so water is either present at the surface, your river, ponds, etc., and or in the groundwater. So here you can see the groundwater this is for Asia and Southeast Asia. In 1900, the global population was less than 1.7 billion. And the groundwater withdrawal was about 500 cubic kilometer per annum. Currently, the population exceeded the 7 billion, and groundwater withdrawal has exceeded the 3,000 cubic kilometer per annum. So it is almost the 6 times. So agriculture is this, I told you earlier also, it is 70% of this user. consistent increase in both surface and groundwater use in worldwide, you can see, and the increase in groundwater use has been increased since 1990s. So if I will tell you that in before 1947 there was abundant of water, or you can see up to 1960 there was abundant of water. But after that, when green revolution has started, the water has been used, and from 90 to 80, lot of groundwater structures developed, but leading to the depletion of the groundwater quantity. And then later the need for the groundwater quality was also felt. And now you can see all the basins, major basins of the world are facing this problem, including the Indus and Ganges basin of the India. So in India, it is Indus basin is in the mostly related to your Indus River, and the Ganges basin, which is main portion of the India, exceeding from the Himalayas towards the eastern parts of India. So this is the Gangetic basin. If you see the global scenario, you can see here the groundwater dependency is increasing, and India is one of the hotspots. This red means there is high alarming and it is highly decreasing. So you can see the 54% of India faces high to extremely high water stress, and mainly it is in the northwest region of the India. And it is also in the south part of the India also, where there are the hard rock aquifers are there. So if you see the global water resource map highlighting the location of regional aquifer system, in our major aquifer system is our Indo-Gangetic basin, but it is well developed through the alluvium, which were brought out the rivers from the Himalayas, distribute sediments in this basin, and it's become very fertile. This basin is very fertile. Lot of crop production occurs in this Indo-Gangetic basin. So it has been estimated that one of the study we have carried out with the team of world, we are the researchers from the USA, British Geological Survey, UK, and I was the leading from the India, and my co-partner was from IIT Kharagpur. So we have done a study for the Indo-Gangetic basin, and we published this paper in Nature Geosciences. It was estimated that the total volume of groundwater is about 30,000 cubic kilometer, about 20 times the compound annual flow Ganges, Indus, and Brahmaputra. And however, as estimated, 23% of this is the saline, and 37% is affected by the arsenic. So here you can say this is the map of the Indo-Gangetic basin, and it has been divided into the various sectors. So here it is the Indus basin, and this is the Punjab part, which is the half, it is the Pakistan part of the Punjab. And here you can see this is the northwest India. And if you see how the groundwater depletion is occurring in the northwest India, it is very high in this part. So if we come to this was that which we have published in Nature Geosciences, groundwater quality and depletion in the Indo-Gangetic basin. And this is there were some observations which are taken from the GRACE data. GRACE is the satellite data which take for the water storage. But we have taken the data from the in situ observations. In situ observations, we have collected the data from the field itself, and then we found this. And then if we see the 3D groundwater typologies, we developed the 7 typologies here. This for the Indus basin, then mid or lower Indus basin, then the mid Gangetic basin, or you can see here the Baltic region, and here on the mid lower Himalaya, lower Indus basin. So this explains the behavior better in this all the basin. All the basin, the situation is not same. These are highly variable. There are cross-border situations. This is published in the Hydrogeology Journal, where it can be, we have described this in detail. And groundwater depletion. If you see the groundwater depletion means groundwater rates, you can see centimeter per annum. So here you can say that centimeter per annum, this is more depletion in this part. So this is the NASA GRACE satellite data. And the most groundwater areas, these are the California Central Valley, where the depletion is 4.8 plus minus 0.4 cubic kilometer per annum. Then the northern China province, where it is 8.3 plus minus 1 cubic kilometer per annum. The northwest India, where the depletion is very high, it is 1.4 plus minus 7.1 cubic kilometer per annum. So groundwater development in India, you can see here this portion, as I told you earlier, this is very important. CGW, Central Groundwater Board, has carried out this study where they have found that from the 6,969 blocks, over expected are 1,114, critical are 70, Semi-critical are 1057, saline 97, blocks that is 1%. So most of the blocks you can see are still 64% are safe, but these are not on the northwest India where we live. These are on the other part of the country. So groundwater decline in some portion it is 0 meter, some portion is to 4 meter, some part it is more than 4 meter, mainly in the Rajasthan belt. So if you see that northern India is going, groundwater is going down and down. So total loss is 109 cubic kilometer. So you can see here, there is no shortage of rainfall. The rainfall is there, but the storage, groundwater storage is depleting with the time. So, and this is the, water is not a bottomless unless we reach the bottom of it. So when it will reach the bottom, this is the largest freshwater bank, freshwater storage for us. We are going to use it, and it will be under stress conditions. Then the rainfall patterns in India, if you see the long-term average rainfall is 1,160 mm, highly variable. It is about more than 11,000 at the Monsoon Ram in Cherrapunji, near Chenjapunji in Meghalaya, 50 mm at Jaisalmer, or maybe sometimes it's less than that in Rajasthan, and highly variable in time. You can see most of the rainfall occurs during the monsoon seasons. So average number of rainy days are very less. Those are 40 in the year. So rainfall temporal variation, how it varies from January to December. Here you can see the main rainfall occurs during June to September. The environmental tracers, which I'm going to focus how we can use in the water resource management. A tracer is substance introduced into the biological organism or other system, so its subsequent distribution can be followed from its color, radioactivity, or other distinctive property. Environmental tracers are ambient, natural, or man-made components which are widely distributed on the Earth's near surface, and these are naturally present in the environment. Earlier, these were introduced into the system since Department of Atomic Energy has banned now the introduction of the artificial tracers. So we rely on the natural tracers. So then what is isotope hydrology? It is the new emerging part of the science. We are a discipline with the investigation to supplement the traditional hydrological evaluation, overcoming many of the involved difficulties and providing new insight into the concerned hydrological processes. What are these isotopes? All are from the science background have heard that isotope is the atom of same element with different number of neutrons. So this makes more neutrons. This make an atom heavier. On the basis of this heavier neutron, it is been detected. And from here you can see isotopes, isobars, and isotope. Isotopes are different. How they move in this chart, you can see here. So I will not go to the detail of the physics. So these are your heavier isotope. Water is, as you all know, this form of HOH. So when it is from the heavier part, that's means HO, H2, or O maybe O7, O18, or H2. This may be your heavier water. So here you can see this is the distribution of this water, the abundance, relative abundance. See, you can see here the vibrational motions of these isotopic effects for these different components. And in addition to that, there are various isotopes of the carbons are also there. So these are the isotope molecules. Generally, from the point of view of isotopes, we use it to fingerprint the water. We can find out through this fingerprinting. So any water, if you come to the lab, if we analyze it and we found that this water coming from this source or this place. So these are the heavier molecules, have lower velocities, as you know, and the lower this, if we have the heavier molecules have greater binding energies now, but the heavier molecules for more condensed phase energy. If you see the classification of isotopes, these are stable isotopes. They are very stable. They don't decay with the time. And I will not go down much detail. And unstable isotopes are those which emit the radiation until and unless they become the stable. And the environmental isotopes may be stable or unstable, which are present in the environment. Those are your environmental isotopes. This is the classification chart of the isotopes, where the stable, unstable, natural, environmental, artificial, and natural are defined. So the isotope fractionate into the heavier and lower molecule parts, and this is what makes the change, because during the phase change, if it is phase change means from the liquid gas or from liquid or gas to again your solid, then again chemical transformation, isotope exchange, means these are some of the processes which takes place during the fractioning of one. This is isotope fractionation. I will not. So here, although they acquire the different characteristics characteristics of the isotope from vapor, rain go to the strips or snow, or that again go to groundwater. This is the ocean water. So the water characteristics, the isotopic composition change. That's why we can identify the source of water from where it comes. So you can say we have carried out a project in DST sponsored 14 organizations were there. We have taken the 20,000 samples from all over the India. This project was led by the ISRO, and we were the part of it, where we have identified we fingerprinted those water from the surface water, groundwater, and also. These are the instruments which use the isotope. These are isotope ratio mass spectrometers. So these are very advanced instruments. And earlier, our institute was ranked in the world, third ranked in the world for the measurement of the isotopes. This is the other instrument. This is the continuous isotope flow. This was the dual inlet, where the reference and the sample they are injected at the same time. Here the isotope reference and the standard are injected continuously, and the helium is used as the carrier gas. So these are the various other parameters which can be measured using this instrument. So these are some of the for dating technique also. In dating, our institute also does the dating. So from the dating, we find out the age of water. What is the age of water? This is called residence time, and we either use see chlorofluorocarbon or tritium or carbon dating. So this is the some of the radioactive and non-radioactive tracers. Half-life is generally when half of the air atom is the that is you can say decade. That is called the half-life. So for hydrogen it is very less. For carbon it is more than that. For chloride it's very high, and for krypton or uranium it is very high. And we can hear the age using this. So these are the environmental data, how the groundwater age is measured using the in years. You can say from 10 raised to power 1, 10 years, to the 10 raised to power 6 is 1 million years. We can find out age of water. So these are the tritium. Is the generally you can see in our air. You can see it is the 14 nitrogen. When it is broken down into carbon and helium, one tritium is you can say released into the atmosphere. So during the bombardment in 1960, there was a lot of tritium in the environment, and its value when it is less than its initial concentration TU, and it is 10 to 15 TU. So if the value is this, means this is a modern water, and if the value is this, so you can say sub-modern water. These are the values of the different which how we can find the age of water. Then this is the approximated ranging of data applications. You can see here radon is very less, 3.8 days, and then more than 10 TU recent groundwater. So 50 year is modern groundwater, and some modern. This is how we did, and this is one of the projects we carried out for Punjab government. We have dated the groundwater for all entire Punjab, and we found out in isolated range, because they have the comprehensive apprehension that the water is moving from the saline water to their portion, but it was not there, because in isolated patches we found the very old water. If it is the water coming from this side, so water would have been the very old, because there was some mixing properties would have been there. So this is the way, this is the various, and this is the how we find the groundwater velocity. If you found the 25 years old water here, and here 3,000 years old, the difference is 500 years old. If we calculate the distance, we can find out water velocity also, water flow direction also. These are the application of isotopes in surface water studies, water balance and dynamics of lakes and reservoirs, seepage and leakage from water bodies, discharge of mountain rivers, sedimentation in lakes and rivers, soil erosion from watershed catchment, and snow melt runoff and hydrograph separation, suspended and sediment transport, sources and tracing of pollutants, paleohydrological investigations. So these are the, and in groundwater also, we can use the isotope for the soil moisture movement, because for the groundwater, water movement starts from the soil moisture itself. So we can find out the soil moisture movement and variation, source identification from where the groundwater, this water came to groundwater, charge zone identification from where the water is going down to the groundwater, and the groundwater residence time, the age of groundwater, salinization, this is inland or in coastal areas, or in groundwater pollution sources. We can find out the pollution source, whether it is from where this pollution is coming, and the groundwater flow velocity. There's a that example in my previous slide, where we can find out flow direction, flow, and then the surface water and groundwater interaction. The groundwater and surface water, they have interacting each other, and they are interacting, and they are responsible for the flow. Sometimes groundwater is also responsible for the flow in the surface water. One of the study was carried out in the Varanasi area by IIT Kharagpur, where they found that the Ganges River groundwater is contributing to the some of the Ganges River also. So then the aquifer interaction studies, we can use this isotope. Submarine groundwater discharge, a lot of fresh water is being go down to the ocean, which cannot be used. So using the submarine groundwater, how this water is lost, how much this water we can quantify using the submarine groundwater, if you're using the recharge estimation also, how much water is gone down to groundwater and it is recharging, because there are a lot of hue and cry because in water conservation and rainwater harvesting for the recharging the groundwater. So recharge estimation can also be found using this pressure techniques. And the recharge effectiveness, how effective a particular part for the recharging the groundwater, so we can use that technique. Then the environment hydrology also, global and regional climate change, we can use this isotope, sources of precipitation and onset of monsoon, contribution of local evapotranspiration in the precipitation, partitioning, evapotranspiration partitioning, we are also using this and tracing out the hydrological cycle, altitude, latitude, and continental effects on the precipitation regime, and environmental pollution. So global pattern of mass in the atmosphere. So isotope methods of recharge estimations are neutron probe method, fission tagging technique, then deuterium enrichment technique, and one member mixing technique. These are some of the techniques which are used for the recharge technique and surface water, groundwater. So some of the case studies are here. Here how we are finding the monsoon dates. These are the dates given by IMT, and these are the dates given by the isotope. So air moisture prior to the rainfall, so that where there is a lag of the period. Here you can see 12 days, 9 days for the different periods. Isotope tell about the south monsoon has entered a particular region or in particular continent. So we can find out how this is the. So this was one of the information for the possibility of using the isotope techniques for monitoring arrival and withdrawal of the southwest monsoon. So here, these are the published in the current science journal. Here you can see these are the various stations we have established: Kakinada, Sagar, Roorkee, Jammu. Find out from the ocean how the air moisture is moving from one place to the other place from Roorkee. We have established in 2007. These are the starting time and the distance from the sea. So you can see Sagar, Jammu, Kakinada, Tejpur, Kanpur, and Manali. So as the distance were moving, so how the vapor is being transported from one part to the other part. So these are the Manali, Kanpur, and Tejpur also. We have established in the IIT Kanpur and the Tejpur University also. So we found from the atmosphere, this clearly tells us that the most depleted part of the isotope, this is from the Manali, Roorkee and Manali, and the most stable, that is near the ocean, where there is no depletion. So we can characterize the source from where it is coming. And here you can see the vapor source can be completely identified. In recharge sources, how the neutron probe, what happens, some neutrons are released into the soil. So these neutrons, they interfere with the hydrogen ions. So when they interfere with the hydrogen ion, the hydrogen potential is less. And due to the less potential of the hydrogen ion that we can measure, you can see the less potential and the more moisture. When the potential is high, this moisture is less. And when there is a potential is low, this means the less moisture is there. So what is this radiation? This radiation are either alpha, beta, and gamma. Alpha radiation can be checked from the single hand. Here energy is very high, but it is not that much penetrating. But the gamma or neutron gamma radiations are very highly penetrating. So you need lead, the penetration power of this gamma radiation. So the neutron probe methods, using a borewell is done, then piezometer is installed. Some of the case studies I am showing you. So we put the instrument in that. I will hurry up. So after putting the instrument, we get this type of curve. From getting this type of curve, we can easily find out where there is a high moisture and where there is less moisture. So when there is a high moisture, means the recharge is taking from that place. These are the peaks we can find out. Then the tritium tagging technique, we also tag the water using the tritium. Tritium is really detected using the background noise or the counts per minute or the this is a Curie, there is a meter Curie or the units. You can see the becquerel or also this is lower cost radioactive material, and assumption is there soil moisture movement is piston flow type. The water coming from the upside, it will push the water in the downside towards the low side. So this is a assumption for this. Then is your charge by, you can see here, you can clearly see the water is moving and the tritium is found here. So more tritium is here. You can find out how the water is moved from the upper layer to the down layer. And then this is the tritium tagging technique. You can see here. I will not go into it. This is from where the different portion of the India, the water estimated recharge were found in the Banda district, Jhansi district, and these are all over the places we have found this area. So this is the actual formulation for calculation of the recharge. And, stable isotopes are also used for the recharge measurements. You can see here or the transient flow and transport flow modeling. So stable isotope methods are the groundwater collection prior to onset of monsoon and the collection of the rainfall samples and the percent of groundwater due to the rainfall. See, this is a formula for the one component or two components. So the peak shift is found here. So we can find out how the moisture is moving from one place. So this is the other technique, deuterium technique. Deuterium is used for finding the water movement. So I will not go into detail. If you have any query, you can come to our office or you can call or you can send an email to me. So I will answer all the emails. What is how the water movements are there and how the tools can be used in the water resources management. So these are some of the case studies. I am moving the slides. So this is how you can make the contours of water. This is ground. This is below the ground or below the surface, subsurface. This is the distribution curve. So from the distribution curve, you can find out the distribution profile of the volumetric water and the soil moisture. So this is the lysimeter. These are various techniques used for the recharge measure. So this I have told you already how we are doing. Isotope characterization. I'll also show you what are the recharge. So this is the project was submitted, funded by the Punjab government. In the same, we found what is the recharge sources, the groundwater. You can see that this is the rainwater. This is, you can say, canal or rainwater. Groundwater. So we found out the different portions of recharge sources. So and we also found the interaction between the various aquifers. Aquifer are storage where the groundwater storage. Various aquifers are in the ground and how the water is moving from one aquifer to the other aquifers. So and even from the surface water and groundwater interaction, this is from the Vyas River. We found out how the Vyas River water is moving with the distance. You can see here, this is not along the river. This is the particular to the river. So we can also find out river water. So these are the Yamuna water. This we carried out from the Agra, Mathura, and we found out the Agra and Mathura water contribution. You can see the contribution of the water to the river water to the groundwater, and sometimes groundwater is also contributing to the river water. So these are the temporal contribution, and this is the some of the water quality studies where we found how the fresh water from the Aravalli belts in the footprint of the Aravalli belts is moving towards the central portion of the Haryana, and how this is again going back, this saline water moving towards the fresh water. This was the found out using various techniques. So these are recharge and seepage from the canals also can be found. Single use dilution techniques. So use of tracers can also be useful in that. So this springs in mountainous regions. In mountainous regions, we can also find out from which altitude is coming, and from it is the from Gomukh to the Rishikesh. So the technique you can see the water signatures are changing. So these are the altitude effect. Then part of this is some of the methodology, and then radon decay. This can also be found out in the. You can see submarine groundwater. We are using the radon. Radon will not be found in the surface water. Whenever there will be oxygen, radon will not be found. So radon will be only found in when the water is subsurface. Its half-life is very less. It is only 3.8 days, and if it is found, means that there is the subsurface water is there. So this is the techniques for the subsurface water where the fresh water discharge can be found out and it can be verified. So these are some of the papers published by us in the using the resort in east coast of West Bengal and in Orissa also. So these are some of the techniques for using in the world also, where they are using the research technique to find out water source. And these are again for some of the case studies from the world. So these are case studies. That to sum up, you can say we can find out the recharge, we can find out the recharge source, we can find out the source, and we can find out the various interactions using the various models. So I don't think if I have taken much more time, I will finish here. I will thank Director NIH for the Director Dr. R.D. Deshpande from PRL Ahmedabad, IA, we are Krishnan Kumar, Dr. M.S. Rao from NIH Roorkee, and thanks to all funding agency for these projects which I have shown you, and thanks to the organizing committee of the ICFMRS-2022, the IFERP team, and special mentor Mr. Karthik Raja and Ms. Sushmita G. They both were in continuous touch with me for this keynote. So I will once again thank both of these. Thank you very much. And if you have any queries, and so I will, I have given my mail address in my first slide. So you can note down my email. And if you have any queries, or the students from the RIT can visit to me here at NIH. And if they have any queries, this is my email address and phone number. So you can note down it if you have anything related to this, or anybody interested to work on the tracer techniques. So with this, I will conclude here. So thank you very much to all for bearing with us, for listening this very carefully. So once again, thank you very much.
Thank you, sir, for sharing your great knowledge with us. That was a really an amazing speech. Your session was full of enthusiasm and valuable knowledge. Thank you, sir. Now it's time for the tea break. I would like to request all our guests to move towards the break. We will resume here at 12 o'clock. Thank you.
Hello. Will you say a little louder, please?
Thank you, sir,
Yes, please.
for sharing your great knowledge with us.
Oh, thank
It was
you.
a really amazing session. Your session was full of enthusiasm and valuable knowledge. Thank you, sir.
Oh, thank you. Thank you very much. Thank you very much for the your organizing team. Thank you very much.
Thank you, sir. Now it's time for the tea break. I would like to request all our guests to move towards the break. We will resume here at 12 o'clock. Thank you. Welcome back. Now we are entering in the first technical session of today. The session chair for the first technical session is Mr. Ajay Singh So, HOD of Civil Engineering, Mr. Minu Rani, Professor of Electronics and Communication Engineering, and Dr. Pavan Gangwar, HOD of Electrical Engineering. Moving on to our first author of this technical session, as I'm going to invite Mr. Shiva Shakti Vadivelan RA is to come on board to present a paper titled on experimental investigation on hyposlurged concrete by using Sikacrete. So sir, kindly open your camera and unmute yourself and move towards your presentation. Thank you, sir. Sivasakti Vadivelan RA. Am I audible to you?
Hello, ma'am. Can you hear me?
Yes, yes.
If the participants are not available, means we can move to the next presentation, ma'am.
Okay, okay.
Okay, thank you.
The next author is Ram Gopal Ramisetti. Please come on board to present the paper titled on a review of construction waste management practices in India, challenges to circular economy. So sir, kindly open your camera and unmute yourself and move towards your presentation. Ram Gopal Ramishetty, am I audible to you? Ram Gopal Ramishetty, are you there? Now let's move to the next. I'm going to invite A.R. Komal Thakur to present a paper titled on Architecture Education in the Digital Age, a comparative study between the academics and practices. So kindly open your camera and unmute yourself and move towards your presentation. Thank you.
Yes. Good afternoon, everybody. Am I audible?
Yes, you are.
Okay, thank you. Good afternoon, everyone. I'm architect Komal Thakur and working as a guest assistant professor in IK Gujarat, Punjab Technical University. And I'm here along with my co-author, Dr. Kanchan Garg, who is the professor and the head of the department of Chandigarh University at University Institute of Architecture. So today we are going to discuss about the architecture education in the digital age with the comparative analysis between the academics and the practice. So we are starting with it because being into this academics, we have experienced experience the things that in education, in architecture education system, where we are lagging behind in terms of the integration of the digital technology in the education system. So this study is basically based upon the information that which we have collected from the literature studies by reviewing the article, journals, research papers, feedbacks, interviews, and as well as our own experience also. So in this, we have done the comparison of the architecture education with the architecture practice, like because what we have seen that in being into the architecture profession, it has been working very good towards the progressive growth in terms of designing the new things into the digital era. So there are a lot of experiments and the experiment with the new forms or the new kind of infrastructure which are being developed and designed with the help of the digital technology. But in architecture education, that we have seen that in overall, if I talk about the in a global perspective, there are few universities and the institutes which are very good in incorporating the digital technology in the architecture curriculum. But there are few ones where we have seen
If you are
that
registering and log in to this Zoom link, right? It will take time, then join.
Ma'am, sorry.
Madam, screen, your presentation is not visible on the screen, madam. Are you sharing?
Yeah, I have been sharing it. Just a second, give me a second.
Ma'am, you did not open your PPT yet.
Yes, madam, correct.
Ma'am, I have, it's showing that you are sharing your screen. Should I share it
Your
again?
screen is being shared, but your PPT is not open, Kamal.
Okay, again, I'm doing it now. Is it visible?
Yes.
Yeah, now it is visible, madam.
Okay, I'm so sorry for that. Okay, so now we are moving towards the study which we have done in the presentation. So me and Dr. Kanchan would be highlighting the information that we have discussed in this presentation. So first of all, we all are very familiar with the aspects that digitalization is very much helping us in our day-to-day life. So with the help of that, it has become very easy to access anything at anywhere and at any time. So we all know the advantages of having the digital technology in our day-to-day life. And if I talk about it, it has been integrated so well into the different disciplines, so that is very helpful to attain the good outcomes, especially in architecture. If I talk about in visualization, the things which was not good in the earlier times, but in today's time, with the help of technology, it is possible. So these are the benefits which we are getting from the technology. So if I would like to talk about the architecture practice with the digital practice, in this we have seen that being an architect, this is what we have seen, that with the help of this, it has become very easy to deliver our work to the client, because it help us to provide the various kind of options, and it provides the opportunity for us to give a wide range of experience to the clients. So with the help of this, it builds a good relationship with the clients, because client is getting a work whatever the architect is trying to give to their clients. And we all are very familiar with the technology like the augmented reality and the virtual reality. These are very prominently nowadays. These technologies are very good in use in the construction, because we have seen that when the things which are still not there on the site, but with the help of the augmented and the virtual reality, all those things are can visualize. With the help of that, the spaces can be visualized and can be experienced with that. So yes, these things are benefiting the architecture profession so well. And with the help of this, with different kind of softwares that are being used in the construction industry while designing the infrastructure, designing the buildings. With that, it can be seen that the information it is very helpful to generate the calculative information regarding the resources which are going to use for the construction. So it is helpful in that. And if in this contemporary era, it is working as a digital medium, where we all might have seen or might have heard about the Zaha Hadid architects and the Norman and Foster partner architects, where we have seen experience with the we have seen their unique buildings. We have seen their organic form kind of a buildings. So with the help of this is only possible with the help of the different kind of technologies that these architects have been using in today's time to do experiment with the different organic forms. So if I talk about the importance of the digital courses in architecture education, because it was very important to understand that what are the latest the status of the digital technology in the architecture practice, but how it is playing an important role in the architecture education, that is equally very important. So basically, first of all, it is important to understand that it enhances the students' learning capacity, because what usually happens is, if I talk about in India, we because when I graduate, we also have faced this kind of a situation. Like when we graduate, we don't know like what industry is expecting from the students, those who are being graduated, because the skills which are need to be have in the industry somehow like in the architecture education, that skills are not that much provided. So somehow students face that issue. But if such kind of courses are integrated into the architecture curriculum, then students can upgrade their skills so that they can prepare themselves for the industry's requirement as well. And these softwares are also very helpful for them to analyze their design in their academic coursework as well. And with the help of this, they can also with the help of these softwares, they can also get to know about the futuristic performance of their design, which is equally which is same being done in the architecture practice as well. So now the main thing is that what are the current challenges and the issues where architecture education is facing while inculcating the digital design courses in the architecture curriculum. The first thing is that it has become like a limited, because these sometimes we have seen that digital technology is considered up to only the like the drafting or the 3D molding tool, but it is not just up to that, it is more than that, because we have seen that with the help of the software, we get to know about the different we can say the with the help of the digital softwares, we get the complete analysis of our building, like the shadow analysis, how our we also get to know about the like the energy simulation of the building, how our building is acting as per the climatic conditions, as per the country, or as per the zone, stuff to drafting purpose. And another thing is this is the main issue, like in this curriculum. So like the earlier I have also discussed that this thing is not in architecture curriculum. These things are not incorporated as well, which industry is demanding. And this is another fact that majority of the students and the educators are not aware of the facts and the potential of the digital technology. So this is another issue. And the main challenge which we have seen is that the traditional educational system in the architecture education, which is still prevalent here, is not giving the opportunity to the another strategy to come into the education and to proceed further. So this thing is the traditional education system is limiting the integration of the digital technology as well. So these are the major challenges and the issues which are currently being faced in the education system. So now I would like to call the Dr. Kanchal ma'am to just to talk about the SDG goals and the architecture.
Thank you, Komal. Very good afternoon to everyone. Am I audible?
Yes, ma'am, you're audible.
Yeah. So when we are talking about architectural education, the practices and the technology within that system, we are talking of the SDGs also, what we call it as the Sustainable Development Goals given by UN. There are different categories, but where an architect can play an important role is the planning of all the goals or targets given by UN, so that those goals, so that those goals could be attained before execution or on the operational challenges. So this is what we are finding out, that sustainable development goals should be a part of curriculum to be attained, that like we are talking about nowadays about the outcome-based education. This is the outcome-based education profile that we'll be looking forward if we are talking about the technology and the softwares in architecture itself. As Komal said right now, that we are talking about CAD as a drafting tool only. But yes, in the development goals, when we are talking about the water levels, etc., as Dr. Gopal Krishnan was talking about earlier, he was talking about the GIS systems, he was talking about the water levels, but what to do with an architect, how architect can take care of that beforehand when he is planning for any type of built up environment in the area. Although it will be along with the collaborative team of urban planners and town planners, but yes, once the architect is talking about the built environment, then SDGs goals are in consideration, will be easy and efficiently done once we are talking about the softwares in that technology. The numbers that we have identified for SDGs are the 4, 6, 7, 9, and 11, where an architect plays an important role, where he can do the planning at the earlier time in the earlier mode, that execution and operational model will be easy. And for that, the architect must be aware of about the ICT tools, including the softwares also, so that it could be incorporated into the drawings before getting for the final approval from any of the departments, either these are the municipal corporations or the urban planners, town planners, anywhere the drawings will be going for the approval. So if we are talking in detail about the SDG 4, it is related to quality education, which is basically linked to the rest of the SDGs. When we are talking about water, the sustainable cities and communities, we are talking about the climate architecture, etc., then it should be inculcated from the quality education, which covers the SDG 4 goal. And it is targeted that by 2030, it should be leading to effective learning outcomes. And these learning outcomes will be possible only if we will be having different softwares in the curriculum. That's what we have identified in our whole research, that a curriculum which is required to be revamped should be in line with the SDG goals also, though it is required in the traditional mode also, because architecture is a field where we can say that it is the hands-on activities. The student must be knowing the creativity comes through the scribbling of different components. But yes, to save the time for different activities, for like we can say is the energy simulation aspects, we can talk about the modeling aspects. If we are talking about Grasshopper, Rhino softwares, any type of softwares which will be giving the immediate outcome, that what the creativity is thinking about in the scribbled form, that will be there in the database in the soft form, that will be covered. Can you please change the slide, Kamal?
Yes, ma'am.
Then in specific to about the climatic data, when we're talking about that the digital earth observation is there, then architect has to plan that what are the digital earth observations are there. So all the digital earth observations will be coming from all the ICT tools and the softwares, or the satellite images or satellite data, etc., which should be there in form of the curriculum. So that right now what we are talking about is that we have the curriculum, like in architecture, we have 50% weightage to the core subjects. But for computer graphic skills, we have only 5 to 10 credits for the out of 270, approximately 260 to 300 we are talking about for the Council of Architecture. But on average, if I am talking about 270 is the credit, then only approximately 10 to 12 credits are being given to the computer graphic skills, which we are finding right now in this paper, that these 10 credits must be upgraded to another level to attain different goals which are required for the different levels of the global requirements. Next, please.
Thank you, ma'am. So now I will be discussing about the three major, I can say the pioneer college of the at the global level, where they have incorporated the courses of digital technology so well in their curriculum. So first of all is the TU Delft in the Netherlands. In this, the main motive of this university is to incorporate the digital technology in the form of a collaborative approach, which is based upon the 5 principles here: embrace open sources, collaborations, open learning, interact with the architects, and combine breadth and depth. So on the basis of all these 5 principles, it is very easy to identify that they are giving a open liberty to their students and their educators as well to go and collab with the architects, with the industry, like what they are doing in their field, and to just know about the facts, like what kind of the latest advancement in the technology or in the field they are expecting from the young graduates. So these are the opportunities they have been adding up in their curriculum, where students are getting the different kind of knowledge from the field. And when they are getting the open learning sources also, and the collaboration with the they are collaborating with the different software developers as well, with the architects and with the other stakeholders, where they can get the information about the different kind of a software architecture, where they can upgrade themselves, they can polish their self, and can get themselves ready for the industry, which they are expecting from the students. And second, second study, which was done by the researchers from the Gazi University, Turkey, from the Faculty of Architecture. In this, the authors have done the comparison between the traditional technique and the digital technique, where they have visualized the architecture design technique through these two methods. So in the traditional technique, it's very simple to identify that the tools are the paper, sheet, pen, and model, and the digital technique is basically the software generator or the computer generator things where the students are working on that. So on the basis of all these techniques, the design is evaluated on the 5 parameters. The first one is the production time. So here we can see that in the digital technology and the traditional technique method, it has been seen that digital
Sorry to
technique
interrupt,
is.
Komal Thakur, but the time limit has been exceeded.
Okay, sorry.
Yes.
So
Can we conclude, ma'am?
Yeah, can we conclude? Yes.
Sorry, I didn't get it.
Can we conclude, ma'am?
Yeah.
Yeah, from the survey, we have found that number of softwares are required by the students, and now the shortage of softwares is there. So to change our global system and the need of the profession and architecture education, it is required that the complete revamp of curriculum is required, and it should be done with, though it has been done from 1972. After then the act was there, 1983 there was a curriculum development, and after that we have the complete revamp of the this architecture education curriculum in recently to 2020. Yet it needs number of changes regarding our software development systems to inculcate into the students, which is required, and we just hope that it should be covered into the curriculum, and it should be covered, and in the next proceedings maybe it could be worked out.
Thank you so much. Thank you, ma'am.
Thank you.
Thank you, A.R. Komal Thakur, for sharing your valuable knowledge with us. Now is the time to encourage the spirit of the next researcher. For that, I would like to invite on board Venkatta Ramana P. to present a paper titled on a novel approach to design a multifunction radar for air and weather surveillance. So, sir, kindly open your camera and unmute yourself and move towards your presentation.
Thank you, madam. Thank you. Am I audible, madam?
Yes, you are.
Yeah, I will be sharing my screen.
One thing I want to tell to everyone, presentation limit is 10 minutes. So within the timing, you all have to finish the presentation.
Madam, are you able to see my screen?
Sir, we can able to see, sir, but you can share your presentation, sir.
Okay, madam. Are you able to hear me, madam?
Yes, sir, we can.
Yeah. Okay. And the screen is visible now. First slide I kept a novel approach to design a multifunction radar for air and weather surveillance.
Yes,
Is
sir,
it
we
visible?
can, sir.
Yes, madam. Okay, madam. Good afternoon. I am Venkatramana, research scholar at Jawaharlal Nehru Technological University, Anantapur, and I am working as a scientist engineer at SDSC Shore, ISRO, and I am under the supervision of my guide, Dr. G. Mamata. I have carried out this activity, what I am going to present. So basically, I will be covering radar. What are the different advancements in the radar technology and what are the contemporary designs that are pertaining to the multifunction radar especially, and what is the technique we adopted and how the cost of the radar is minimized by adopting the novel technique. So this is the basic summary of my presentation. The introduction. So as all of us know that radars are now have become a very common and very critical technology. This is involved not only in military purpose, they are more into the civilian domain also for weather monitoring, atmospheric research, air traffic control, and precision landing of aircraft and collision avoidance, etc. So all these radars which are up to now are there, they are mainly optimized for a single function. So technologies are now being developed for getting the multiple functions in a single radar so that we can have the major advantages like cost and what is the space which is occupied for the each radar installation and maintenance, etc. So that is the state of the art technology now in the radar field. You can see that in the slides. I have put four different types of radars for weather monitoring and air surveillance and precision velocity estimation and long range tracking. So if you see that the slide right side, this is the what are the one radar which is able to do ECCM and dedicated tracking of any special object and air surveillance and target classification and defense for point defense purpose. So all these things are now possible in a single radar because of the advancement in technology, and there is a lot of development in the recent days which I will be covering. So this is called multifunction radar, where a single radar can do the functions of multiple radars. So that is the definition of multifunction radar. So in various countries, there are different multifunction radars are already being developed, but there are some disadvantage of that. Majorly is the cost, and the technology what they are adopting is not still matured, and it is not practically possible to deploy in the operational system. So like in UK, BAE Systems is the one of the company which is doing this type of development. They have developed and demonstrated the technology for air-cooled TR modules, real-time control, digital adaptive beamforming. All these things are they are developed, and they want to use this technology in the their radar what is going to be developed. So that right side down second picture is showing that one. So then similarly, USA also has got multifunction RF systems which are to be integrated, for communication as well as for the tracking. The same radar antenna to be shared, all these type of with the help of electronic beam steering and active array concept they have used. So advanced multifunction RF concept and integrated topside, that is the project name, and multifunction active electronically scanned array, MESA is the some of the projects they are taking up. So similarly, there is a civilian application that is for the tracking, weather surveillance and air surveillance. So which is the program name is called MPAR, multifunction phased array radar, which is aimed to replace all the weather radars that is called NEXRAD radars in the US, which are used for the weather monitoring purpose. So all these radars have to be removed and kept with a multifunction radar called MPAR, and it also serve for the weather surveillance as well as air surveillance to protect their motherland. So this is the basic concept. Why this is done is because of the two reasons. One is they want to have the unified hardware and software and some of the flexibility to avoid high power devices like tubes based transmitters. So these two are main motto, so that they can minimize the cost of maintenance as well as the development cost also to be minimized. For that, they envisage that this can be done because of economies of scale and logistical simplicity and leverage technology from the wireless industry, because wireless industry are now developing a high power chips, so which can be used as a TR module, that is transmit module in the radar. So that is the basic concept. That's what they are motivated by that one, and they have started developing the project called MPAR. So I will be covering more on that MPAR and how our technology is adopted is more advantageous. So what are the challenges in multifunction radar development is efficiency of individual function, because it has to be demonstrated for multiple functions. So each function has to be performed at a faster rate. So, and also each function, if it is done alone, then it has got better efficiency because of the hardware or software what we optimize it. So in spite of that limitation, we should develop a technology such a way that it will have equal to the individual functions capacity, as well as, if possible, better than that. Then dual polarization is the one requirement for the weather forecasting. It is not required for the air surveillance. So that means it should have the vertical polarization as well as the horizontal polarization, which will be enabling the radar to predict the type of precipitation, like it is ice or water, or it is a hail or snow. Such type of thing will be only available with the help of dual polarization. So this dual polarization will be used for this type of radar will have some disadvantage if you use the electronic beam steering. So if you steer the beam by plus minus 20 degrees, so the polarization purity is lost. So to overcome that, we need to have some dedicated algorithms and some complex calibration methods to take care of this type of polarization mismatch effects. Then digital beamforming is a technique which is used to have all the information from the antenna to be digitized immediately, and then process the echo in a computer, so that we can define multiple beams, and at the same time we can have the whatever the required information within a single transmit beam we can acquire and process it. For that, there is a complex hardware, that is ADC requirement of sampling at higher rate, and process definite rate of the much faster rate is required to have this type of technology. So that's why it is still have to be more evaluated, and it should be feasible for the implementation in the for longer systems and larger systems with low cost. There are systems which are available, but this cost is very much high. So then, when vulnerability of single point failure, because if 2 or 3 functions are combined into one radar, and if this radar any component fails, if the redundancy is not sufficiently built in, and even if it is built in, so there is a possibility of failure any component, which is not possible to have the redundancy. So such components fails means then 3 radars are not there, equivalent to 3 radars. So if the function is having surveillance, tracking, and weather surveillance, so 3 radars dedicatedly are there. Now these are all incorporated in a single radar. If the single radar fails, then 3 radars are failed. That is equivalent to that one. So that means that is a vulnerable to single point failure. So we need to have the sufficient redundancy at the radar level itself. So that is the one solution we can able to find out. Then complexity and cost. So as this is already told that a single function radar can do with mechanical steering of a parabolic dish, but this what are the techniques adopted by the all the existing radars are electronic steering. This electronic steering is possible only plus minus 60 degrees. That means 120 degrees of the coverage area only is possible with one array. So that means to cover the total 360 degrees of azimuth and elevation from 0 to 90 degrees, we need to have at least 3. But practically, the people are more preparing for 4 radar phases, 4 radar arrays, so that 90 degrees plus minus 45 degrees only can be steered, so that the beam shape losses are reduced. That means 4 radar arrays are required for each covering the each 360 degrees of azimuth and elevation plus 0 to 90 degrees. So that means it is equivalent to 4 individual radars of electronic scanning radars. So that is the complexity. So then if 4 are there, arrays are kept on a single platform, the mutual interference because of the all the 4 arrays have to be operated in a single thing. So there is to be some interference will be there. For that, we need to enhance the spectrum also, because each can be taken with a different a type of frequency. That is, frequency bands can be separated so that we can avoid this one. Then the motivation for the development of MFR is, so what is the just now previously I talked MPAR, which is nothing but the development which is carried out in US for the civilian application for air surveillance as well as weather surveillance. They have adopted this type of technology where 4 arrays are used and they can be used for the both the purpose. So this the estimation of cost, and they have already done some trial basis. One radar is deployed, a scaled version. So they estimated the cost is $12 million. So $12 million is the cost of one multifunction radar. Now, for because it has to be maintained redundancy, so 2 radars are required, which will cost $24 million. But what we have developed one radar similar functionality that is costing only $2 million. So with this $2 million, we can actually deploy almost 10 radars. So in these 10 radars, if we apply for 0 to 90 degrees, one radar only will scan. Other radar from 90 to 180, like that. If you divide that total sector into 4 and assign to the 4 radars, then it will cover 4 sectors within a faster time. And also the cost is minimized. So only 2 into 4, almost $8 million itself will be the cost of the 4 radars. And for surveillance, only 1 radar is sufficient. That is, 5th radar can be deployed for that. So that means within $10 million, we can able to achieve the goal of all these things. But all the 5 radars will have the common software and hardware also, and we can define the function. Based on the function, we can use for that radar as for weather surveillance or for air surveillance. So this is the concept adopted by us. And with this, what are the advantages we are getting is, so it also uses the phased array technology, but it will not steer the beam electronically. It will steer the beam mechanically using a traditional servo controller. So with this, the limitation of the polarization, that is, if we steer the beam plus minus 20 degrees apart, we'll get the polarization mismatches or polarization purity is lost. That can be avoided. And we can still take the advantage of the phased array technology, where we can synthesize the different beam width. For surveillance, we require a larger beam width. For the weather forecasting or weather surveillance, we require a short beam width. So this can be taken up, and TR module will be used so that that large power, average power required can be synthesized. And pulse compression technique with large bandwidth can be utilized, so that will improve the range resolution. So all these advantages we have incorporated, and it is realized a scaled version, that is the specifications of beam width of 1.5 degree and polarization is both vertical and horizontal with 40 dB gain and side lobe level of minus 20 dB. One more advantage is we can apply the side lobe level reduction techniques, which are useful for the reducing the side lobe level without hardware. With the software itself, we can able to get the side lobe levels reduced to whatever the required level. So this is the concept. 1 kilowatt TR module is utilized, and it will be divided into 64, 1:64 power divider it will be given, so that 64 elements will be fed with a single and TR module, so that traditional normal whatever the electronic steering radar requires actually in this case 64 TR modules. Now we require only 1 TR module, but as we don't have electronic steering, there is no limitation. We can change the spacing among the elements also more, so that we can have the less number of elements, so less number of TR modules. So with this one, we have got the total antenna realized like this, which is shown in this figure, which is mounted on a platform to make it rotatable. And you can see that the corners 4 elements are removed, 4 tiles we are calling them. These are removed because we want to achieve the whatever the side lobe level required as a 16 dB by this itself. This is called thinning effect, where we remove some of the elements so that we will get the less side lobe levels. In the graph, you can see that here we are seeing it almost 16 dB down is the side lobe level, and gain is 32 dB is the array gain, and 8 dB is the each patch antenna gain. So put together 40 dB gain is achieved. So what is the conclusion is, this is the methodology by adopting mechanical steering with array technology. This is called hybrid technology, we can say. So with this type of technology, we can achieve the multifunction capability with less cost, and we can have the better reliable system also. There will be redundancy built in, because we can already 4 radars are there. Any one of them fails, the other radar can be configured for that. So the goals of the MPAR, which is nothing but common hardware for all the radars, different types of functions, and faster rate. The scanning should be faster, because we are employing 4 radars, so that we can able to do the faster scanning. So like this technology is adopted, and we are realizing a radar also. It is now being operationalized, and we are in the process of evaluating the radar. So this is the references I have gone through, and these are all the what are the references I used for this presentation. Thank you, madam. With that, my presentation is concluded.
Thank you, sir, for sharing your reflective knowledge with us.
Thank you, madam.
The next one is Muninder Singh Chauhan, but due to some emergency, he is unable to present his paper now and scheduled for the next technical session. Now is the time to cheer the strength of the next researcher. For that, I would like to invite on board S. Preeti to present the paper titled on development of ketoshan graphene oxide and cerium oxide composite blended films, anti-cancer, antimicrobial and antioxidant studies under in vitro conditions. So ma'am, kindly open your camera and unmute yourself and move towards your presentation. Thank you.
Good afternoon, ma'am. Can you hear me, ma'am?
Your voice are not clear.
One sec. Can you hear me, ma'am?
Your voice is breaking. Is there any network issue? Kindly check.
Yes, no. Can you hear me, ma'am? Now it's clear, ma'am. Hello, ma'am.
Yes.
Can you hear me, ma'am?
Yes, yes.
Okay. Ma'am, can you screen my screen, ma'am?
Yeah, it's visible.
Thank you. Morning to one and all present here. I'm here to present my paper on title Development of Titrazine Cerium Oxide and Graphene Oxide Composite Blended Film with
Miss Preeti,
Anti-Cancer. Yes,
your
ma'am.
voice is completely glitching.
One second. Ma'am, now it's clear, ma'am.
No.
Hi Preeti, there is some audio glitches from your end. Can you remove
Yeah, your
heads?
voice is now clear.
Yes, can you remove headset or you can directly speak? Or else try another headphones.
Okay, ma'am. 1 second, ma'am. Can you hear me now, ma'am? Hello, ma'am. Hello, ma'am.
Yes.
Can you hear me now, ma'am?
No, your voice is not clear yet. Please check if there is any connectivity issue. Hello, Miss Preeti. Miss Preeti, am I audible?
Hi Preeti, can you check your mic, and if you have facing some issues means you can present later. Hello?
Yes, ma'am. Can you hear me, ma'am?
Yes, we can hear you, but your voice is not that much clear.
Give me 5 minutes, ma'am. I join.
So, can you check once and can you present later?
Later.
Yes, please. Thank you.
Yes, ma'am.
The next one is Ms. Sushma S. Jagtap. She will be going to deliver knowledge on the topic EEG-based emotion analysis using deep learning model. I would like to welcome Ms. Sushma S. Jagtap to come on board to present their paper. So ma'am, kindly open your camera and unmute yourself and move towards your presentation.
Ma'am, this is Ramya H, ma'am. Shushma Hess is my author name, ma'am.
Okay. Now you can proceed.
Ma'am, can you see the slide, ma'am?
Yes.
Good afternoon, everyone. I am Ramya H. My project domain is EEG-based emotion analysis using deep learning model. EEG stands for electroencephalogram, which is commonly used in medical and research area, which is used to record the biopotential from brain by placing the electrodes on the scalp. Here I have completed my BE in Electronics and Communication Engineering from Rajalakshmi Engineering College in year 2017, and I secured first class with a distinction, and I am here to complete my higher studies in ME Communication System in the same college. In the abstract, it is very convenient to employ the EEG signal for capturing various applications because it is non-invasive and portable. The BCI, it is a brain-computer interface. It is used for understanding the person inner state of the emotion, and the emotions are the affective state which influence the human behavior, and it will improve the human relationship and human-computer interaction. The main objective of the project is to identify the emotion of the EEG signal using the deep learning techniques. And it has a development of low cost. It is easy to analyze the brain activity which is associated with emotion. Currently, there are different types of brain-computer interface device which is available on the market. In this method, I am going to analyze the algorithm using CNN, which stands for Convolutional Neural Network, along with the deep data set. It is nothing but depending upon the time the person signals are extracted, and finally, it is labeled as positive, negative, and neutral. The raw EEG data is processed by the convolutional neural network, which is used to extract the time invariant feature, and the deep data set, it is used to categorize the person emotion. Finally, I'm going to compare the classification performance of the convolutional neural network algorithm based on the performance metric of accuracy, precision, recall, and a FM score. Using the deep learning techniques in the convolutional neural network algorithm, the deep data set, it is used to analyze the patient emotions such as positive, negative, and neutral. In this CNN model, the modules used are input image, data pre-processing, data visualization, classification, and a performance metric. Finally, the CNN model is implemented, and the accuracy result and the classification report are generated in the system. To implement the CNN model, the first step to collect the data set. Here the deep data set, it is used to implement the CNN model. The second step is data reading. The third step is data pre-processing, which is used to convert the raw data into a clean data, and it describes the 5 types: EEG data, head, tail, describe, shape, and data types. In EEG data head, it is used to print the starting values of the data set. And in EEG data tail, it is used to print the lost values of the data set. The describe, it is used to find the mean and standard deviation value. And using the shape, we can find how many rows and columns are present in the data set. And finally, the data types, it is used to find the float and the integer points of the data set. The final CNN model is implemented and the accuracy results are predicted and the classification report is generated. In classification report, it has totally four metrics: precision, recall, FM score, and support. In the data visualization, the specific data sets are localized and the sampling data sets are stored as a variable name as EEG data. And the patient emotion are classified into three classes: positive, negative, and neutral, which is labeled as 0, 1, and 2. The 0 represents negative, 1 for neutral, and 2 for positive. Here the figure 1 shows the three classes of patient emotion: positive, negative, and neutral, which is plotted as a separate graph. And finally, all the three classes are combined and plotted as a single graph in figure 2. To implement the CNN model, that EEG data are trained, tested, and further it is pre-processed, and the specific data sets are taken to analyze the human sentimental state of three classes: negative, neutral, and positive. And therefore, the CNN model, it is compiled and the approaches are used to run 15 times to get the better accuracy result to implement the CNN model. And finally, the accuracy value for the convolutional neural network is 97.812%. The classification report is generated in the CNN model, which has 4 metric: precision, recall, FM score, and support. Using this 4 metric, the CNN model performance can be calculated for negative, neutral, positive, accuracy, macro average, and weighted average. The negative for the precision is 0.97, for recall is 0.98, FM score is 0.97, support is 0.201, and the neutral is 1.00, for recall is 0.99, FM score is 1.00, for support is 231. For positive patient emotion, the precision value is 0.97, for recall is 0.97, FM score is 0.97, and for support is 208. The accuracy value for FM score is 0.98 and for support is 640. The macro average for the precision is 0.98, for recall is 0.98, and also for FM score is 0.98, for support is 640. Finally, the weighted average for the precision is 0.98, for recall is 0.98. Same value for the FM score is 0.98, and finally the support is 640. Conclusion: using the deep learning techniques, it is used to classify the emotion of the patient and also to find the changes in the brain activity. The deep learning, it is one of the popular technique to be used in the CNN algorithm. And therefore, the EEG based emotion is analyzed by using the convolutional neural network algorithm, and I proved the best results in terms of the accuracy prediction of 97.812%. These are the reference papers of EEG based emotion using deep learning techniques. Thank you, ma'am. Ma'am? Can you hear me, ma'am?
Thank you, Susmita, for sharing your insightful knowledge with us. I would like to request session chair, Dr. Madhvinder Saxena, to raise a question.
Yes, very nice presentation. Can you give me the EEG waves and the frequencies? What type of a EEG waves?
EEG waves, so we can say the beta, alpha, gamma. Using the different types of frequency band, we can able to find the EEG waves.
Yes. What is the frequency of that waves?
Frequency minimum it has 0.66 0.60 above. We can find the frequency band.
So the main challenge of this project is to how you will measure and measure these waves, and how you can feature extraction is to be there. These are the very low frequency waves. So what type of a hardware and software you are using for that?
The software I used is a Jupyter Notebook. Using Python programming, I implemented the CNN model.
Okay, it is the final you have done the well, but
No,
starting in a hardware, we want something how you can measure the low frequency wave. Which hardware you will use for the measure this data?
Still, I used the deep data set to classify the CNN algorithm, sir, but this is a small project because still I have to find the BI-LSTM algorithm, and finally I have to prove the best accuracy results, sir. It is on the process, sir.
I can understand your result, and this result is really appreciable. But I have found the where you can find the right hardware where you can measure and extract these waves. This is the base of this project.
No, it is generally to find the patient emotion, whether positive, negative, and neutral, sir. I'm just plotting it in a graph. I'm showing the difference between these three classes.
Okay, thank you. Thank you very much.
Okay, sir.
Yes, next.
Now is the time to share the strength of the next researcher. For that, I would like to invite Piyush Petkar to come on board to present his paper titled on a comparative study of few image processing algorithm. So sir, kindly open your camera and unmute yourself and move towards your presentation. Piyush Petkar, are you there? Piyush Petkar is not here. So kindly, I am proceeding for the next one. I would like to invite Tanaya B. Dehotunde on board to present a paper titled on smart traffic control system. So ma'am, kindly open your camera and unmute yourself and move towards your presentation.
Just a minute, ma'am. I'll share the screen. Is my screen visible and I am properly audible, ma'am?
Yes, you are audible and your screen is visible.
Okay. Okay. So, good afternoon, everyone. I'm Tanaya Dahatonde, and it is my honor to be a part of this conference and present a research paper in front of such esteemed dignitaries. So, the title of our project is Smart Control System. The authors and the co-authors are me, myself, Tanaya Dahatonde, Sorali Damle, Pratik Dagre, Harshal Daigavani, and Prajwal Damle. Our research guide is Professor Surbhi Kakade, who has done a wonderful job of guiding us throughout the course project. So, let us take a brief overview of our project. So I'm sure nobody among us is unfamiliar with traffic congestion on the roads. The list of negative repercussions of traffic congestion is endless, but to name a few, air pollution, accidents, fatigue, increased gasoline use, etc., are just at the tip of the iceberg. Also, there are several challenges associated with traffic management systems, such as unreliable technology, incapacity of the current system to incorporate new technology costs, etc. This is where a smart traffic management system comes into the play, which tries to address all these issues. Coming towards the description of our project, what we had done is, we developed our project using OpenCV, which is an open source computer vision library, and we had used ESP32, which is basically a Bluetooth and Wi-Fi based module, a microcontroller, which is cost effective and low power. So camera provide a live feed. Image processing on this live feed is done with the help of OpenCV, and the data is interpreted and converted into the required format. This helps to detect the number of cars, and the microcontroller will facilitate this whole process and control the traffic lights in the real time. So this is basically a flow. So if there is a car detected, then by the presence of cars, if it is yes, then the current signal stays green till a set time. Like normally the set time for the traffic signals is of 20 seconds. And if it moves on, then the next signal turns green. So traffic light work as normal as long there is no interrupt detected by the microcontroller. Interrupt to the microcontroller is provided by the microprocessor hosting the image processing on the live feed provided by the camera. The camera provides a live feed on the traffic that is waiting and incoming at the crossing. Microprocessor, with the help of image processing on the live feed, finds the number of vehicles in the roadway with the active green light. If, in case, all the vehicles have crossed before the time, then interrupt resets and sent to the microcontroller. When the microcontroller receives an interrupt, it changes the current active green light that is turned off and the yellow light is turned on, followed by the red light. The next roadway is green. The next roadway is turned green and the time again resets for the 20 seconds. If the microcontroller does not receive any kind of interrupt, then time runs out. Signal works as usual and the next green light is turned on. So this process is repeated each time. Yep, so this was all about our project. To conclude, a smart and efficient traffic control system is successfully developed and tested using the ESP32 OpenCV, which will help in the better traffic flow and ease of the management of traffic congestion and roads and highways. Further improvements can be made in this project to make it more robust and efficient. These are some of the references or we can say the research papers which we had used. Yes, so that's it from my side. Thank you so much, ma'am.
Thank you so much, ma'am. I would like to request session chair Dr. Madhavendra Saxena to raise questions.
Oh, very nice presentation. Have you implemented this idea in anywhere in the country?
So like on a large scale, we had not using this, but as a scale down model, we are trying to, and we can implement it.
Where? In Pune? In which city?
Yes, sir. Like in the metropolitan cities, we can use it, which will save the time of the people.
In Pune, there is a Deccan is to be there. Have you implemented there? Or you are trying to implement it there?
Yes, sir. Like we are planning to do so, but no idea till yet, sir.
Okay, thank you very much.
Thank you, sir.
Very nice.
Thank you, sir. Thank you so much.
The next distinguished to honor us with her presence is Kaushalya Naidu. She will be going to deliver knowledge on the topic of hand gesture wheelchair control using Raspberry Pi. I would like to welcome Kaushalya Naidu to come on board to present her paper. So kindly open your camera and unmute yourself and move towards your presentation.
Thank you so much for letting me be the part of this prestigious conference. I will be presenting my screen right now. Is my screen visible?
Yeah, it's visible.
Okay. Hi, my name is Kaushalya Naidu, and my project and presentation and research is regarding hand gesture control wheelchair using Raspberry Pi. I was guided in this project by my professor Vishal Gaikwad. So basically, we all know what a wheelchair is, but in my research and my project, I have added the control that I can use to move a wheelchair with the help of hand gestures. So I basically planned it for some elderly and disabled person, because a traditional wheelchair is really difficult for persons to use. So the project that I made was low cost and it was efficient to many people who cannot afford an expensive project. This proposal that I made is basically on vision-based methodology. This is my flowchart of the presentation, the prototype that I made. So as we give a hand gesture to the camera, the camera can recognize my hand gesture, and then it sends the signal to my algorithm that is in the Raspberry Pi. And if I show the one finger, my chair goes forward. If I show two fingers, the chair will go into reverse. So it's the basic algorithm that I prepared for my wheelchair. This is my block diagram that I prepared. A block diagram, as you can see, there is a Raspberry Pi, and the Raspberry Pi is connected to the camera, the SD card where my fingers and my gestures are saved. Then it is connected to a relay driver. As soon as I give a gesture to my camera, the information is passed into my Raspberry Pi, and Raspberry Pi gives my relay driver to move forward or reverse the wheelchair. My wheelchair is operated by the power supply unit that is given to it, and the keyboard that I used for my in my wheelchair was to add node MCU into it and give instructions as such as I also installed a small keyboard in which if I click a button, my fan would be turned on with the node of MCU. So the application it will be really comfortable and convenient for anyone who has a heavy weight and who can take trolleys. And it will be really easy only by signaling through your fingers. These are the references that I used, which are presently there in the market, or the research papers that have been given. Thank you.
Thank you very much, ma'am. I would like to request session chair, Dr. Madhavendra Saxena, to raise a question.
I have a two question to you. In this project, when you are going to conduct this project, what are the two challenges you can find to solve this problem? And there is a very critical problems are to be there. So what are the two key challenges are to be there?
The problems that were faced by me while preparing this?
Yes.
Yeah, the major problem that I had was the power supply, because the amount of person sits in a chair depends, and the power supply depends. And if a heavy person sits into a chair, then how much power supply should I be giving to the person? That was a major thing that I had an issue with to reconsider it with. And the second was algorithm. It was a bit of difficult for me to prepare the algorithm properly, because if I was giving the instruction to go forward, it was going backwards. So these are the two major difficulties that I faced while preparing for this.
Okay, thank you very much. That's a very nice presentation.
Thank you, sir.
Now the next one, I would like to invite on board S. Preeti to present the paper titled on development of ketosane graphene oxide and cerium oxide composite blended films, anti-cancer, antimicrobial, and the antioxidant studies under in vitro condition. So ma'am, kindly open your camera and unmute yourself.
Ma'am, can you hear me, ma'am?
Miss Preeti, are you there?
Yes, ma'am. Can you hear me, ma'am? Ma'am? Can you hear me, ma'am?
Yes.
Yes, Preeti, we can hear you.
Yes. Good morning to one and all present here. I am here to present my paper on development of chitosan, graphene oxide, and cerium oxide composite blended films with anti-cancer, antimicrobial, and antioxidant studies under in vitro condition. My guide name is Saranya J, MTech PhD, with she's an assistant professor, and myself, Preeti S. In day-to-day life, cancer is considered to be one of the deadly disease which has always caused a great threat to people's health. So the treatment for various types of cancer such include surgery, chemotherapy, and radiotherapy. These methods are most costlier. So for these, usage of nanomaterials leads to it's most cost effective. So I have chosen this paper as my project, and my abstract of the project is to prepare chitosan, cerium oxide, graphene oxide ternary nanocomposite with a simple wet chemical procedure. These nanomaterials are separately analyzed with the physical and chemical properties such as XRD, FSEM, FTIR, and as well as TEM. After this analysis, it's further developed into a thin film device. After constructing this thin film device, it is subjected to an MTT assay test. This is my phase 1 project. The description of my project is synthesizing the chitosan, cerium oxide, as well as graphene oxide as a nano-ternary composite. Here, after here it is analyzed with the nanostructures. These nanostructures are analyzed using XRD, SEM, TEM, and as well as FTIR. In XRD, that is, it is used to find the crystalline nature of the nanomaterial. The SEM is used to find the surface morphology of the nanomaterial. This nanomaterial has some particle size that is analyzed by the TEM analysis, and FTIR is used to find the surface morphology of the nanomaterial. After the analyzing the physical and chemical properties of the ternary nanocomposite, it's further developed into a thin film device for taking this test to validate for various cancer cell lines. So coming to the conclusion, here I have prepared the nanomaterials step by step. First, for the preparation of cerium oxide, it undergoes various processes. That is, for cerium oxide, I have taken 0.1 grams of serous nitrate hexahydrate, which is dissolved in 100 ml of distilled water. After keeping that solution on continuous stirring, we get a brown solution, which leads to the preparation of cerium oxide nanoparticle. After preparing cerium oxide as a nano material, it is further developed into the characterization, and this preparation of graphene oxide is done using Hammer's method. Hammer's method, in the sense, graphite powder is added with the H2SO4 and it's kept in an ice bath. After that, 1 grams of NaNO3 is added to that solution and it is preserved, which leads to the preparation of graphene oxide. The chitosan preparation also leads to the same process, but it undergoes various types of process such as demineralization, deproteinization, and deacetylation. After all these preparation is done, these 3 nanomaterials is further analyzed with various physical chemical properties. Physical chemical properties, and it is further subjected to cancer assay tests. Thank you. Thank you.
Thank you so much, ma'am.
Thank
I
you,
would
ma'am.
like to request session chair Dr. Madhavinder Saxena to raise questions.
Are you hearing?
Yes, sir.
You have not put at any SAM image or a TAM image.
Sir, I'm on processor. The first The nanomaterials are now only prepared, sir.
Yeah,
After that,
only sample is prepared.
yes, sir.
So in which lab you have working in this for the nanomaterial?
Sessions Biological Lab, Ashok Nagar, sir.
Ashok Nagar, where it is situated?
It's near Vadapalni, sir. You know, it's Chennai, sir. Chennai, yes, sir.
Okay, Chennai. Now, so when you are going to next presentation, please make a one image and morphology image on that way.
Okay, sir.
That will complete your paper. Okay, thank you. Very nice presentation.
Yes, thank you, sir.
Thank you. Thank you.
If anyone is missed to present, if there Next, I would like to welcome our honorable keynote speaker of our conference, Dr. Adrian Clegg, Associate Professor and Vice Director, Institute of Radio Communication, Poznan University of Technology, Chief Architect and Board Members at Remodo Labs, Poznan, Wielkopolski, Poland, to give his keynote speech. Let us, Dr. Adrian Clegg's scientific passion on wireless communication started while he was studying electronics telecommunication at Poznan University of Technology. Since then, his vocational interest focused on various aspects of physical MAC layers of wireless communication systems. In particular, my MSc was devoted to HSPPA solution, highly emerging technology that time, 2005. During his PhD, my investigations were associated with non-orthogonal multi-carrier system, adaptive transmission schemes, software-defined and cognitive radio. His PhD on new transmission scheme with non-orthogonal waveform was awarded with the first prize in the main national contest for the best PhD thesis. The domain of study became so interesting and involving that his valuation degree was related to numerous aspects of intelligent resource allocation in wireless network 2019. Currently, he is an associate professor at Faculty of Computer and Technology, and my professional interest includes cognitive and software-defined radio array and virtualization, dynamic spectrum sharing and advanced radio resource management, advanced multi-carrier transmission schemes, FBMC, NOFDM, GMC, etc. Application of database, radio environment maps, context information, big data, and AI solution for wireless communication. I would like to invite Dr. Adrian Cleggs. Please move forward.
Okay, thank you for this very kind and nice introduction. I mean, could you please confirm that you can hear me well, or do you have some issues with the voice?
Yes, everything is well.
Everything is well. Okay, so good afternoon. As far as I know, it's an afternoon on your side. So good afternoon, ladies and gentlemen. I would like to warmly greet you from Poznań, University of Technology in Poznań. So it is in Poland. So on opposite side of the globe. So with great pleasure, I welcome, all of the, persons present there physically and remotely. So all the session chairs, presenters, all delegates to this nice event, International Conference on Future Roads of Multidisciplinary Streams. I think it's quite important to really look on on everything from multidisciplinary context. So it was my great pleasure when I was invited. So my great pleasure was to accept this invitation, and I'd like to thank all the organizers for inviting me and all persons involved in monitoring that everything is done correctly and done on time. Saying thank you again, I would like to start my talk, which is somewhat scheduled to more or less 45 minutes, if I'm not wrong. Sorry also from the delay in the beginning. I have some issues. The system doesn't allow me to join, so I have to log in a different way. But anyway, everything is now working, so it's fine. While selecting the topic, I wanted to share with all the participants of ICFRMS some findings and some solutions that potentially could be an issue in the future. So as it was mentioned, my interest was on dynamic spectrum access in different contexts from last year. One of these areas of my interest. Here I wanted to concentrate on vehicular aspects and vehicular application of this dynamic spectrum access. So VDSA in a nutshell. So some research questions and results that we have achieved and some future roads. I'm highlighted here, but this is the work that we have done within my team. The team working with me, and some persons are listed here just for recording. So the outline of the talk is more or less the following. So we will start with the motivation, then and scenario definition. This will be somehow connected. Then one by one, there will be some measurements, results, and application of edge intelligence for autonomous platooning, because this was the use case that we have selected for more detailed investigation, and at the end discussion if we will have some time. So let's start with the motivation and problem definition. So as probably all we know that, in terms of, many things are happening related to application of wireless communications, and one of these areas where wireless communication plays a significant role is the vehicular world, meaning that we foreseen that in the future the transportation and all the communication using cars and other vehicles will look completely different than for now, and the steps towards this direction are also somehow highlighted by some international organizations, and there are three use cases that are of interest. The first is extended sensors. So we simply assume that there are many information sources, and we exchange information between all the participants of the traffic. And then we have autonomous driving and remote driving. So autonomous is well known. Remote is that we are steering the car or the vehicle or drone or whatever remotely. And the platooning as one of the probably the simplest applications of autonomous driving. And in our research, what we were considering is the application of wireless communication solutions and some advanced use of spectrum, and towards autonomous driving, and we focus mainly on platooning as the first step for the autonomous driving, autonomous platoons. These aspects have been already discussed and somehow specified within 3GPP and all other related or similar organizations. Here, I will not go into detail of the meaning of all the numbers, but we can see that the third column with the numbers, it deals with reliability. Of course, it is quite obvious that if we assume that all the cars and all the vehicles and participants of the roads, they that everything should be safe, then it means that the wireless communication has to be highly reliable. High reliable means that we have at least this 5 nines or 6 nines, as we can see here. So only very small % of messages could be corrupted. And in fact, our expectation as humans from the computers and all the systems is that they should not make any mistakes at all. So it means from the technological perspective that we should achieve very high reliability. So again, the similar slides, what are the challenges? So from the technological perspective, we will need to deal with, as we mentioned, high reliability and ultra low latency, which is very important. We see that the environment and everything is changing highly dynamically because of, all the cars, all the people, drones, everything is, moving very often, very fast. So it means that the environment, everything is changing highly dynamically. So it generates a lot of issues and problems, technical challenges. So we should have an ability to make mobility decisions. So to change the lane, to stop, to brake, or to accelerate very, very fast, much faster than it is done for the human. And probably we should consider all participants on the road as the source of valuable information. So we should apply some crowd sensing. And this everything means two things, at least two things. First, that again, the wireless communication has to be extremely reliable. And then we should apply some advanced solutions to support decision made by all of the participants of the road. So it means at the end that some sort of edge intelligence could be applied, and we foreseen that this could be a very good approach for improving the distributed intelligence or the edge intelligence, junction of both of these approaches together. This could be one of the enablers for the future transportation systems. If we go to some background, what we have now in terms of wireless communications, there are two dominating approaches. The first one on the right side that based on the infrastructure. So we have all the CV2X solutions, so cellular vehicle to everything communications. And here we may say that the right side is infrastructure based, the left side is infrastructure less, meaning that everything is highly distributed. So we have all the solutions based on IEEE 802.11p and wave standards, and these are working well. We know that the frequency band, which is considered as 5.9 gigahertz. The technology is there. All the intelligent transportation systems are there. They are working fine, but more and more frequently, even more official bodies and organizations, they are raising some of the challenges. The challenge is that, this is the figure that probably all of us know very well. So there is a huge number of vehicles. Here we have vehicles, but in the future we may foresee that instead of the vehicles, we will have drones. Drones that carry people, drones that carry some loads, some packages, whatever. As an addition to cars, as addition to some scooters and all the moving objects. So we may see that, of course, the density, heavy traffic leads to some congestion, not only on the road, but immediately the heavy traffic leads to congestion also on the vehicular channels, on the spectrum related to vehicular communication. Simply as more vehicles are there, then more packets have to be sent. So that means that the capacity of the channel, of the wireless channel, simply will achieve its limits. So it at the end means that we are not able to guarantee safety. So at the end, the system will not work. And these observations, I mean, what we foresee, what will happen in the quite near future is that the frequency spectrum which is devoted for the ITS is not enough and will not be enough. So it means that we should find either some new spectrums, and these are some trends that we can observe on the international level, but also the other one is to apply one of the considered concept is to apply the dynamic spectrum access. So usage of the spectrum which is currently unused by other system for that purposes. So this is quite a fresh idea. I mean, there are not that many work on that, but it is somehow promising. Another motivation for the work is that again, based on some measurements, I mean, these are related to what I said before, but if we made some calculations and made some experiments with autonomous platooning. So we have a platoon of cars that we have typically the leader, and the leader is controlling the behavior of the followers. So of course, there are a lot of gains by such an approach. So we have lower costs because in the autonomous cars, we do not have drivers. And then we increase the road capacity in general because we can reduce the distance between the cars, and at the end we also reduce the consumption. Here it's mentioned of the fuel, but we have to understand that it's not only the fuel in the broadest sense of electricity, or whatever fuel we will have. But then, based on some measurements, I will not, of course, analyze because we don't have much time in details, but based on the measurements, if the number of cars per lane in some specific distance is around 20, which is not that many, then we will observe for the current CACC, so cooperative automatic cruise control solutions, there is some lower band related to crash ratio. So of course you would like to have that it will be 0, but as the number of cars increases, then currently we observe that there is a drop in the correct reception rate, which immediately translates to the increase ratio. And then the proposed system in our research is the following. So we assume that the use case that we are considering was first to apply VDV, vehicular dynamic spectrum access, to use some other frequency bands unused by other systems, or use them intelligently to support vehicular communications. And here the key concept, or one of the key concepts, is that we apply some databases. Some of them we call it wide range database, which can save some information that is not changing that rapidly in time. Then we have some intermediate databases and something which is located at the edge, and also some distributed intelligence. So we have the edge of the network and also distributed intelligence within the platoons, mainly within the platoon leaders. So the first car typically, but it is not necessary that the first cars. We can see that as all of these cars will use the same frequency band, or may select, or if they will have the ability to select the best frequency for transmission, then probably we will be able to remove the problem or minimize or alleviate the problem of channel congestion. So for what I'm showing now is the generic setup for all the other results and all the discussions that I will follow. So we assume that, with the reason that I presented previously, we assume that the control channel, which is specified in the standard, may be congested, as we observe in the normal traffic. Then we apply the white spaces, TV white spaces, just for simplicity, but it doesn't matter. It can be whatever white spaces. Or we have also applied higher frequencies, exactly 26.5655 gigahertz. For additional communication, exchanging control information. And we assumed application of vehicular dynamic spectrum access, and the goal was to propose some fancy stuff to implement this vehicular dynamic spectrum access. We have selected for the, let's say, some real experiments, real-time, real-world experiments, DTT band because of its stability, and so we were able to do some measurements on time. And also, we focus on intra-platoon traffic offloading only from the CCH channel in congested 5.9 gigahertz band. By assumption, we use radio environment maps. So these are the databases which save different kind of information that could be supportive for vehicular dynamic spectrum access, and we apply some intelligence algorithms, edge intelligence. So artificial intelligence applied at the edge of the network algorithm to support VDSA. Okay, so REM collects all the data from the vehicles, process it, and improve and somehow improve the database for better functioning of the network. So again, now, as I said, we will have two two parts of the talk. The first one is on measurements and channel modeling. So all the measurements that were necessary to further proceed with the final experiments, and then some experiments with the edge intelligence. So this is done in two parts. So first, again, we assume that we will offload some traffic from the nominal frequency byte 5.9 to other frequencies. So in our case, it's TV white space. So first stuff that we need to do is to be aware of what is happening in the spectrum. So what we did is that we apply some real-time measurements to see what is the occupancy of this particular frequency band. So here we can see there is the map. Poznan is the city where I am now when I reside and the university is located in. So here we see the university is on the border, let's say, some of the city. So we selected the road of more or less 30 kilometers. Where half of it is on the high-speed road. On the left side, we see all the details for the measurements, so some dedicated spectrum analyzers with some discon antennas and some dedicated cables. At these locations, we have measured quite a high number of IQ samples, and then based on some processing, we were able to measure what is the presence of the signal from all the DVB-T towers. So this location of DVB-T towers and the distance from this road are marked here by this black dots. So for example, this I hope that you see the cursor, then this DVB-T tower, the distance from this particular tower is only 4.5 kilometers. So the signal from this one will be quite strong. So what is important, not going into that technical detail, and just to have the message from this part of measurements, is that this is the fragment of the road, just 5 kilometers, as you can see on the horizontal axis. Different colors means different frequency band. So we can see that this violet line is the minimum threshold, the minimum power that is necessary to decode the DVB-T signal. So everything what is above this line could be potentially decoded by any DTT receiver. What will be below that line, although we see it, although we noticed it, it will be not decodable, so we'll not be able to decode it. What does it mean to us? It means that if we, with the dashed line, we can approximate this rapidly changing values of the received power. So we could approximate it, and these approximations have been saved in the database for further analysis. And this is one of the key message from that measurement. And then we may observe that there are areas, for example, here, where the signal is going down. So there will be some hundreds of meters where there will be a gap, a white space. This probably is not that useful, but also what is promising, there are areas which are, for a longer time, there are 3 kilometers, which are fully out. These are not used. So we can simply use them. For a while, we can see their signal is a bit stronger, but then again, it goes down below the threshold. So it means that for almost the whole duration, the whole length of this road, we could use this particular channel. So this could be used to offload some traffic. Once we achieve the area where we have to protect the TT signal, then we will switch to another channel. Okay, so this is one thing, but I mentioned that beside the TV white spaces, we also did some measurements on the high frequency bands. And the issue is that as in the literature, you can find a lot of channel models for different frequency bands, including higher frequencies, even 16 gigahertz. And what we wanted to do is to measure, I mean, first statically and then in the dynamic fashion, what is the really path loss in the real conditions, in real traffic conditions on the highway, which, I mean, there were no or very limited number of contributions in that area. So what is the real path loss if everything is moving on with the typical traffic conditions? So what we did, we now switched to 26 gigahertz, and this is the setup that we have applied. So we have spectrum, we have signal generator on the 26 gigahertz on the left side with some horn antenna, and then also we have the antenna on the receiver side with dedicated spectrum analyzer. And the scenario in practice looks like this. It was that called as it is called today also in Poland. We set different configurations of cars. So either 0 cars, 1, 2, 3, or 4 cars, and we measure the impact of the location of the antenna. So if it is mounted on the bumper, on the windshield, on the rooftop, and there are different distances. And we measure what is the impact of when the static scenario of the cars to the transmitted signal. I will not analyze all these numbers because this, I mean, useful, but just to mention, just to show that all of these values have been analyzed and detailed. And what we have noticed, which is somehow expected, is that the higher the antenna, the lower the attenuation. But of course, we see that the attenuation in general increases as a function, as a number of cars, which is also expected. But the key was to verify the setup. Once the setup is verified and we see what is the real impact of the car and the static environment, we move to the dynamic channel measurements. Of course, the setup is quite similar. So we have, I mean, the results that I will show now, these are only for the location on the rooftop, but we have, we are now post-processing all the measurements with the antennas mounted also on the bumper and below the car in different locations below the car. So again, I mean, during the dynamic measurements, what was important was to have also the GPS measurements, and I mean, the setup was much more complicated, but finally it was successful. The road was quite similar to what we did in the past, but it was extended also to the rural areas. So the first road, number 1, this road is the road is the highway. This road number 1, and the road number 2 is more on the rural areas. So the setup was quite similar in terms of used hardware for the transmission and the reception as in the static scenario. And then what was important was to distinguish 3 situations, to distinguish between these 3 situations. The first, and when you have line of sight, when we see the transmitter directly without any obstacle between the transmitter and the receiver, which is here on the left top corner. Then on the right side, if there is a truck or whatever car driving between us, then it's still line of sight because we can see the car here, but then it is obstructed line of sight and non-line of sight. Of course, this division is not that precise, and this is a long, I mean, quite vivid debate in the literature and also in the community how to do this efficiently. We made it as it is commonly agreed after doing a frame-by-frame analysis of the recorded video, and then we labeled all of the measurements with loss, unloss, and so on. Based on that, we were able to, I mean, these are the samples, I mean, the glimpse of all the measurements that we did for different, for the loss channel, for the all loss channel and the N loss channel. Some of the samples rejected because we have identified as not useful or wrongly collected. And then we were able to approximate the channel with the dual slope approach. And these are, of course, not to remember, but these are the path loss models, propagation models for the directional antenna, and similar results for the omnidirectional antenna. Of course, it's not for now, for this keynote, is not to remember all the details. This is more to have in mind that first we have collected a database of what is happening in the spectrum where we are entering as guests, and then we have measured in real world what is the impact of moving objects on the high speed scenario on the rural areas, also inside the city, and we have calculated the real and proposed the real path loss propagation models for different frequency bands. This will be the input for the more theoretical work how we can apply the VDSA in that scenario. Okay, so by saying this, so let's go for the next part of this talk. So let me recap briefly that we consider the presence of some intelligence, artificial intelligence, and machine learning stuff, and all of these elements. Intentionally, we assume that the car is not equipped, and so far in this investigation that I will show the results for, we did not assume that there is an intelligence inside the leader, but it is not, of course, forbidden. So any distributed or federated approaches we have considered as well. But still, the key concept is that knowing that all the measurements, all the entries, I mean, we have populated the database with all the entries that I have shown in the past and apply some intelligence here to improve the VDSA. We first start with some problem definition. So there is, of course, some math behind of that. So if we will, of course, again, I will not analyze all the details, just the key concept here. What we wanted to achieve is that we would like to maximize the probability that any pair of cars can communicate. So it means that the probability of any wrong of wrongly delivered packets will be minimized, and the probability of reliability will be as high as we can achieve. So of course there are some constraints. First, there will be some constraints or signal to noise ratio, signal to interference plus noise ratio. This can be mathematically expressed like here, where of course this P is the received transmit power, some channel coefficients, noise interference from other platoons, other cars, and also interference from other cars on the right side and from the primary systems in the middle of the denominator. Of course, if we go into the hardware and all the limitations from the hardware, we have to remember that if we have the transmission of the signal, we observe some leakage of the signal. So, I mean, it is obvious that none of the electronic elements are ideal. So we have to somehow consider the non-ideality of the hardware that we are applying. So this is somehow reflected by the adjacent channel interference ratio, ACIR, in all cases. So again, not going into these details, this can be transformed into the mathematical problem formulation, and we have solved and tackled this problem in different ways. First, I mean, we apply some scenario. So for the computer simulations, we have the case as you can see on the slide. So there are two platoons, quite a number of other cars. There are some jammers intentionally, so some users that behave not that let's say fair. Simply they jam to somehow disturb the communication. From our perspective, it means that we have highly increased traffic in the network. So it means that we have somehow forced the situation that we observe congestion in the normal traffic and 5.9 gigahertz. We apply CACC in our simulation, and it is assumed that non-platoon cars transmit the CAM messages in the control channel every 100 milliseconds. And by saying this, we apply some theoretical analysis, and we start with the brute force, and then we see that if we do nothing, so this is probability of successful reception. Of course, it should be 1, and this is the number of. So again, remind me that we have the platoon that consists in our case of 9 cars, so the leader, the first one, and all the followers. So we can see that the reliability of communication between the first and the second car and the first and the third car is very good, because it is almost 1. This is what we wanted to achieve. But then we see that if we are more distant from the leader, then this probability of successful reception drops down. And if we apply some very simplified techniques to select the best channel, we can see that we observe improvement. But of course, one will correctly say that what does it mean? 92 of reliability is useless, and this is true. So, and this is also reflected in the situation that if we consider how we protect the primary signal, it is not that well achieved. So it forces us to find some more sophisticated solutions where we apply some optimization techniques. We apply some, being inspired by some behavior of some flies and fighting bumblebees. We have applied an algorithm inspired by the biology here. We applied some assisted optimization. I'm not showing all the details because it's not the target of it, but first we start with this brute force, and then we applied a couple of optimized solutions that simply prove the validity of this concept. So again, we have the data for the population of the database. We have proved theoretically that VDSA as an idea can be applied efficiently and successfully. And then we go for the last part of this experiment. For the work that we wanted to achieve is to see if this could really work in practice. So the scenario was that we have the cars, which are in our case they mimics the real platoons, and the concept was that they are driving on the normal way, normal traffic, and they are communicating with the databases deployed along the somewhere in the infrastructure. We may say it was cloud native approach, and they exchange some data asking what will be the best frequency channel for me, for the platoon, to offload my traffic because the channel is congested. Sorry. So again, what we did there is, you remember that figure on the right side, it was saved in the database. We call it a radio environment map. So this simply what was the case that there we sent a query. The database was performing some optimization, some calculations, and then there is a response. Of course, the first question that immediately appears, come on, but what will be the impact of any delay, processing delay, communication delay, and so on. So this was measured in one of the first experiments. So what is the issue? The issue is that we have a car here that sends the query to the database. So we have an action update positions, latitude, longitude, so VDSA processing, and the reply could be that channel 5 is whatever it means. Channel 5, it is correct. Previously it was channel 1, now the instruction, the suggestion is to move to channel 5. Cool. But then what we see is that if we look on the time domain, then we see that this processing, it requires some TD1 seconds or time slots, then this processing requires some more time slots, and then TD2 also requires some time slots. Then if we go to, okay, so now we look in Europe we have GPS, whatever GNSS localization system we will use, then this causes and the popular application, this causes some location issues, some location errors. So the immediate question is, if we will drive, let's say 120 kilometers per hour, will all these delays play a significant role or not? So that was the first experiment that simply I'm just showing some results here for this question. So again, the road, you know that road, so we are familiar with the road. And then here you can see that this is the ideal channel selection. So this is the I mean, what will be the best channels from the brute force analysis based on our theoretical approach? So in this particular location, the best channel will be either the black one, which is 506 megahertz, or this blue one, which is 514, or there are some small red dots where 498 will be the best one for selection. And then this is the ideal as the reference. What should be achieved? It could be ideal, but of course there are some issues. But in general, only 1% or less than 1% of the decisions were wrong. So this dots here, these represents the places where there were some problems for some time and some distance where the decisions were wrong. We have measured that the difference between the location of the prediction of our algorithm here and the ideal solution was around 5 meters, which was acceptable. And the key issue was that here you see the histogram, the distributions of different delays. And we can see that for example, the processing delay at the server side is just 0.02 of the second, so 20 milliseconds. Then the difference, I mean, the request sending is just 0.16 seconds. So these are negligible, we may say. The main impact was due to some latency introduced by the GPS. But still, the final conclusion was that using the commercial of the shelf and I mean networks and devices, we were able to achieve the satisfactory results. And what we did, I do not have the results for that, unfortunately, but because this is under processing. But what we did, it was the final experiments where we drive with the normal speed on the highway, so it was even 120 or more kilometers per hour, and we were sending periodically requests reporting what is our location. Then the database collects all the data from all the cars involved in the experiments. I mean, there are some of them, and then calculates what could be the best channel considering the presence of the DTT receiver. So this is what we have done, and then some future plans for the last 2-3 minutes. So that figure is probably well known because it's one of the trends. I mean, I provide the source of it, one very, very cool paper which summarizes some trends for the 6G. And what is important and why I'm showing this, that here we can see some enabling technologies as exactly edge intelligence and also some I mean, some other, but from our perspective, I wanted to show is this edge intelligence, and on the left side of this edge AI, we have this communication with large intelligent surfaces, and this somehow motivates us to do some further step on this multidisciplinary area, because I mean, radio reconfigurable intelligent surfaces. So as you can see on the slide, so these are the surfaces that can be controlled and somehow impact how the signal is propagating. So with the recess, what we can do is that, for example, we can imagine there is an obstacle. So the user number 1 is not easily accessible from the base station perspective, but with the recess, we can efficiently deliver the signal here. What we have considered is that we apply again some edge intelligence with some presence of some edge databases and so on to support this communication. And in particular, what we are considering is exactly the case where we want to support the CV2X or DSRC systems with the recess, also for drone steering and tracking, assuming also that we have some context information databases on these AI tools. As I mentioned, we have developed federated learning approaches, some Q-learning approaches, deep learning, and then other stuff. I didn't show it for the time limitation, but okay, we have it. So now our goal is to see if there were some recess deployed, and I mean along the street, if we could support the transformation of the signal in such a way that the reliability will be achieved in much better way. So just to say that what the results are based on some research from the last project started in 2018, and the future work is for the project that started right now. So thank you. I see exactly 45 minutes has passed. Once I was connected, so I hope that I was in time, and maybe there's a time it is allowed in the conference for maybe one or some questions if you have. So thank you again.
Thank you, Dr. Adrian Cleggs, for giving your valuable speech.
Thank you.
Now it's time for the lunch break. I would like to request all our guests to move towards the break. We will resume here at 2:30 p.m. Thank you.
Any questions?
If anyone have any questions about this presentation, they can ask.
Okay, so I believe that there are no questions, and I mean lunch is very important for sure. So what I wanted to say is really it was a pleasure to share the results and some view on vehicular communications with you. So I wish you, I mean, of course, I mean, bon appetit, and something good to eat, and also nice conference, nice evening for the rest part of the day and tomorrow.
Thank you so much, sir. That was
Thank you very
an
much.
amazing presentation.
Thank you also for inviting me. Goodbye.
Okay, sir. Bye-bye. Now we will resume here at 2:30 p.m. Thank you. A very good afternoon to all. Now we are entering in the second technical session of today. The session chair for the second technical session is Dr. Madhavinder Saxena, Professor of Mechanical Engineering Department. It will be my honor to invite Shushila Rani on board to present the paper titled on, sorry, it was a mistake. It will be my honor to invite Pradnesh Ramesh Padwe to present a paper titled on effect of grinding process on difficult to machine materials analyzed by integration with Internet of Things, a methodological review. Please unmute yourself and turn on your camera and move towards your presentation.
Yes.
No, you are not audible. Your voice is glitches.
Can someone please? Hello? Is my voice audible, ma'am?
Yes, now it is.
I hope I'm audible.
Yes,
Is
you
my
are.
voice clear now?
Yes, it's clear.
Yes, is my voice clear now?
Your voice is
Hello?
clear now. Kindly start with your presentation now.
Okay, thank you. I'm sharing my. Yes. Can you able to see my presentation? My screen? No.
Yes, we can.
Okay. Very good afternoon to one and all present in the meeting. Today we all have seen that the technology has reached to the next step, and now majority of the industries are converted from the automotive automation to the smart manufacturing. So the biggest challenge for these small scale industries or medium scale industries to convert their machineries into the smart. So by considering that perspective, I, Pradnesh Ramesh Padave, presenting a paper, a methodical review on the effect of grinding process on difficult to machine materials, which is analyzed by integration of the Internet of Things. I'm doing my PhD from Mechanical Engineering Department from Devi Patil College of Engineering under the guidance of Dr. Vinay Kulkarni, Associate Professor, Mechanical Engineering Department, Devi Patil College of Engineering. Basically, we all know that the grinding process is considered as the finishing or a super finishing process. So, considering the advantages, it is used over the entire variety of applications. The majority of our applications we can able to see in the sector of automotive. But as the advantages are there, certain limitations are also there. That it consumes some more energy for the processing, as well as it affects the environmental because of the excessive use of a coolant. So to overcome these issues, many researchers have worked on the various aspects to work on the limitations of this. And from the research, the researchers have developed different techniques like graphite grinding, shape adaptive grinding, liquid nitrogen grinding, then minimum quantity lubrication, etc. The main objective of this paper is to investigate the different processes which are used by the researchers for this difficult to machine materials, as well as different grinding wheels used by these researchers and the cooling techniques used to minimize the human hazard as well as environmental sustainability. As we have known that the grinding process is preferably used for the precision finishing, it helps to enhance the productivity. So whenever we come to the, whenever we are expecting the quality product, grinding process is always preferable. But the major disadvantage in the grinding process is we have a limitation of material removal rate. So in order to enhance the material removal rate is the biggest challenge. So by considering that limitations, researchers have developed the different technique. As we all know that the grinding has various types like surface grinding, cylindrical grinding, internal grinding, centralized grinding. But this paper majorly focused only on the surface grinding process. So in the surface grinding process, researchers have found out these 5-6 techniques are majorly used in the industries. So basically creep-feed grinding majorly focused on the higher depth of cuts that we can achieve through these processes. Then shape adaptive grinding majorly focus on the difficult to machine materials. Ultra precision grinding is again used for the high quality as well as hard to difficult machine materials. Then high frequency dip grinding is used for the high wheel speed with relatively high depth of cut. Ultrasonic assisted grinding, which helps to improve the machinability of hard to cut materials. And the rotary ultrasonic machining is considered as the non-traditional hybrid machine process, which used to perform on the ductile as well as brittle materials. When we see the grinding wheel, basically the specifications are involve five different factors. The major role is played by the abrasives. So whenever we remove the material, the rate of material removal rate is completely dependent on the type of abrasive we used. Basically, aluminum oxide and silicon oxide are used for the materials which is having hardness less than 30 HRC. But when we have to work on more than 30 HRC and we have to achieve a higher depth of cut, then there are other abrasives preferable like CBN and PCBN. Likewise, depend on the requirement of the surface finish, the grain size increases. As the grain size reduces, we can achieve the higher and smoother surface finish on the object. The grinding wheel materials also played a very vital role. In this material, as we can see that ceramic aluminum oxide, silicon carbide, aluminum oxide is widely used category, whereas to machine the harder materials, preferably CBN or PCBN, that is polycrystal cubic boron nitride and polycrystalline cubic boron nitride, electroplated CBN, diamond and high-speed tool steel is preferred. For example, if you want to turn the high carbon, high chromium or else EN series materials, then preferably these materials are always used, as we can able to achieve a good quality product and higher depth of cut from these materials. Cutting fluids also plays a very vital role, but as we know that the excess use of cutting fluid majorly affects on the environment, as the disposing of this cutting fluid is very difficult. That is the reason why the researchers mainly worked on minimization of this cutting tool. So cutting fluid. So whenever researchers worked on that different aspects, they have come across the concept MQL, that is minimum quantity liquefied. Generally, for normal operations, for traditional operations, it required 250 to 300 liter of water per hour for the machining processes, whereas MQL required 50 to 100 liter water per hour for the processes. So that is the advantages of this process, that we required 1/3 of the oil, and this MQL technique involves the pressurized flow with the help of compressed air. So compressed air with these nanoparticles as spread on the material while operation, so that the better results can be achieved. Now, the surface grinding majorly affects on the integrator of the surface. So the surface has majorly affected. The parameters which majorly affected in the surface integrity is the surface roughness, hardness, residual stresses which develop during the operation, then grain growth, microstructure, micro hardness, budding forces, and tangential forces that can be affected majorly. Now, this is about the conventional techniques that developed by the researchers. The biggest task is to make the machine smarter. Now, how to make the machine smarter? That connect the machine with the IoT architecture. So basically, IoT architecture involves the input parameters. Input parameters like machine tools, the materials of work, material of your tool. Then the main is the input parameters. So input parameters are fed into the machine, then the machine process start. In association with the conventional machine, the additional architecture, the additional structure of IoT is attached to the particular machine. That machine involves the IoT architecture mainly involves the mechanical conversions, mechanical linkages, electrical signal analyzer, in-process signal analyzer, and thermal analyzer. So we can attach different sensors and transducer to trace the different signals from the machine during the operations. As the heat affects a lot because there is a huge pressure, huge forces acting on the workpiece. So heat is a main concern, which results in the deformation of the material, as well as vibration is generated during the operation. So vibration is again one of the major concern, as well as the wear of the tool is again the big concern, which can also be tracked or easily analyzed by IoT architecture. And the output that we can achieve is the technical aspects, like the signal variations. Generally, when we perform the operation, we will get during or if any variation comes, then we can able to achieve the highest peaks or lowest peaks on the idea whether there is an issue with the workpiece material or whether there is an issue with the grinding material, and we can take the immediate action so that further the next cycle or next operation or next processing of the grinding will be smoother and defect free. And it is also economical output, as it gives the previous result before breakdown or before processing of the wheel. Generally, grinding will require a dressing process. So the dressing can be easily identified with the help of CCD attachment to the IoT system. So that thing is considered as an output parameter. Now, when I refer to paper, mainly I have focused on the key highlights of the paper and the limitations of the paper. The limitation of the paper is basically the area, the research area where the future work will, it is not yet worked by any of the researcher. So first paper basically focuses on the complex filler material, and the main limitation of this is wear rate increases with the increase in speed is observed in the process. In the second paper, it is observed that the high plastic deformation was observed during the process because of the normal force in chip formation and the tangential force acting on the workpiece. The third paper mainly focuses on the need of development of the bonding technology, as we know that CBN and PCBN are basically used to machine the harder materials. So in order to get the perfect machining of the head, we required something new technique for a bonding purpose. So that is the limitation for the identified from this paper. The next paper mainly focuses on the redressal cycle of grinding wheel, which has to be increased by the as per the requirements of the industry, and mainly. Yes.
Sir, your time has been exceeded. Please conclude.
Hello. Oh, okay. Just 2 minutes, and I'm about to finish. Yes. Okay. Thank you. So future, as I discussed, the future scope of this paper is up to till date maximum 100 microns depth of what is achieved by the researchers. So the future scope is increase the depth of cut more than 100 HRC, and which will reduce the deformation.
So your voice is breaking. Mr. Pradnesh, are you there? Thank you so much, Pradnesh Pavade. Now it's time to cheer the strength of next researcher. For that, I would like to invite Sushila Rani to come on board to present root cause of failure in gas turbine blades.
Yeah, good afternoon to all of you.
Yes, ma'am. You are audible.
Yeah. Wait. Sir, my screen is visible to all of you?
Yes, ma'am.
Okay. Yeah, good afternoon to all of you. So my work is root causes of failure in gas turbine blade. Myself, Dr. Sushila, and I have with me my co-author Vedant Prakash Singh is also present here. So first of all, I have tell you regarding the work that I have done. As you people know that in a gas turbine blade, mechanical power is produced by utilizing the energy of burned gases, which are operate at very high temperature and high pressure. So when the failure in the gas turbine blade takes place, it leads to shut down the power plant, and which result in economic loss as well as the service to the mankind is also stopped. So it is a very good area for the research. So I can find out or I can study in this work the various ways in which the turbine blades are failed in gas turbine. So the most common failure mechanism includes fatigue, creep, oxidation, degradation of coating of turbine blade, corrosion, erosion. So the failure of gas turbine blade doesn't take place only because of only one. It may take place by the combination of two or more than two mechanism. Among these, it may be failure plus corrosion. So this research work provide a better understanding about the root causes of turbine blade failure, as well as I take one real failed gas turbine blade from Inprastha gas power plant, and I diagnose it to find the root causes of its failure. So in this diagram, I try to interpret the weight percentage of failure which occur in gas turbine blade by various mediums. So the gas turbine blade problem accounts for 42% of the total failure in gas turbine. Since we know that the gas turbine faces high pressure, high temperature, high stress, and a potentially very high vibration environment. So all these lead to the failure of blades due to overheating, due to fatigue, due to some other reasons, say sulfidation, HTSC, that is a high temperature hot corrosion, and LTAC, that is a low temperature hot corrosion. So now I take one by one to understand these things clearly. So first I take overheating. Since I said turbine blade face high temperature, high stress, and potentially high vibration environment, so there are many things which cause failure in turbine blade. So the very important one thing is overheating, as it is work at very high temperature environment. So blades which are damaged with the help of flying debris and overheating. So in this diagram, I took two types of blade. One is the high pressure side and other is the low pressure side. Actually, may in the turbine there are various stages. The first stages we say low pressure, and the above we say high pressure. These are the two turbine which are failed in different stages. First figure shows the failed high pressure gas turbine blade due to overheating, and the second figure shows the failure or damages in low pressure turbine rotor blade assembly. Resonance at critical speed produce high dynamic stress, which lead to fatigue problem in turbine blade. The common cause of vibration in turbine blade is nozzle passing frequencies, chokes, and blade flutter. In resonant condition, the amplitude of vibration is so high that there is a vibration increases drastically at resonance condition. And if the damping is inadequate, or rather I can say insufficient for absorption these vibration, then they grow further, and failure occur by over stress or by propagation of fatigue crack. So high cycle fatigue problem will occur when the stress level are above the fatigue strength, and low pressure fatigue occur as a result of start and stop. As we know, at the start and stop we have to increase and decrease the speed. So this may also result in fatigue problem, which are come under low cycle fatigue, and these are basically happening normally in the bores and bolt hole areas of the compressor and turbine disc. Then these are the some pictures we show you. The first picture show you how the fatigue crack propagates. So there is an initiation at the leading edge, show the final fracture area, and there is other edge you will get the fatigue crack propagation area, which is the initiation area. Then figure 4 show you the high cycle fatigue, and figure 5 show you the whole area which show low cycle fatigue. Then we have high temperature oxidation. So when nickel-based superalloys, which are used for manufacturing the mainly turbine blades, are exposed to temperature which is as far as greater than the 1000 Fahrenheit, high temperature oxidation occur. So what happen in that oxygen present in the gas stream react with the nickel alloy, and it form nickel oxide layer on the airfoil surface. And when this blade is subjected to high vibration, due to this nickel oxide layer trying to spell out or crack. As shown in figure, this is the oxidation of turbine blade. Then we have sulfidation. As the name says, it is a reaction with the some sulfur part which is present as the impurity in the burnt gases. So sulfidation is a reaction that occur when sulfur react with the protective layer and attack the base metal. The air ingested by the gas turbine contains various properties such as SO2, SO3, sodium chloride, and chlorine. As these impurity pass over the airfoil, droplet of sodium sulfate form, and sodium sulfate is highly corrosive in nature, so it give rise to the pit, and pit act as a stress riser which may lead to the formation of crack initiation. Then we have high temperature hot corrosion. So high temperature hot corrosion takes place at temperature between 815 degrees Celsius to 950 degrees Celsius. So by the reduction of sodium sulfate, sulfur is released, and this sulfur diffuse inward and then react with the chromium to form various salt, chromium and sulfides. As corrosion proceeds, these sulfide are penetrate and form more complex unstable metal oxides. Then low temperature hot corrosion occur between 593 to 760 degrees Celsius. It is result due to the low melting of eutectoid compound which are formed by the combination of sodium sulfate and some of its alloy with nickel. So low temperature characteristic, the difference between the two, that is HTHC and LTHC, that is a high temperature hot corrosion and low temperature hot corrosion, is that in high temperature hot corrosion you will get intergranular attack, but in low temperature hot corrosion there is no visibility of any intergranular attack and no sulfide particle are found in that. So I take this diagram show you how the blade work. So this is the upper part of the blade which is in phase with the burnt gases, and the lower part is inside the rotor. So there is a temperature difference. The upper part work up to 1900 degrees Celsius, while the part which is inside the rotor is about 700 degrees Celsius. So you will get high temperature hot corrosion, that is sulfide formation in the upper part, while in the lower part it is inside the rotor, so there is no sulfide, but the material get expel out in that part also. So this is the SEM pictures we show you high temperature hot corrosion and low temperature hot corrosion. So you will see in the picture also in high temperature hot corrosion you will get corrosion pit which act as a crack initiation, and as more and more load is applied on it, this crack propagate and leads to the fracture, which is due to the fatigue. While in case of low temperature hot corrosion, you will see there is a chromium nickel sulfide only, which may spell out the surface. Then I took one blade from Inprastha gas power plant situated in Delhi. So this blade is first stage gas turbine blade of 30 megawatt gas turbine, and it is made up of nickel based alloy which is Incolan 738, and it is operated at temperature 1104 degrees Celsius, having pressure 10 kgf per centimeter square, and it rotates at a speed of 5135 rpm. So in order to identify the root cause of failure, I have cut a specimen about 1 centimeter square from the leading edge at different height. Then I polish this specimen. I have done all the metallurgical operations which we done to see the structure of the component inside a microscope. So I do dry polishing, I do wet polishing, then I clean it with acetone, and then I saw this structure of this specimen under a microscope. So I will get these results. There is a corrosion pit, and at the corrosion pit it is very clearly seen that corrosion pit act as a stress riser, and there is a crack initiation, and after the application of load this crack propagate, and through this crack the sulfates are goes deep inside and form the more complex compound, which result failure of this turbine blade due to hot corrosion. So I have written a Hitachi S3700 Newton scanning electron microscope equipped with X-ray diffraction spectrometer were used to observe the fracture surface morphology, microstructure, and chemical composition at different region of the trailing edge of the turbine blade. In the microstructure, corrosion pits are clearly seen, and the hot corrosion product penetrate deeply into metal through this initiated crack and result in crack propagation. Then I have concluded that different root causes of failure of gas turbine blades such as fatigue, corrosion, oxidation, sulfidation are discussed and presented in order to provide better understanding of turbine blade failure, whether it is a material defect, maintenance defect, or it may be arise due to the vibration. So I have discussed all these three,
Sorry to
and
interrupt,
then
ma'am, but your time has been exceeded. So you can
sir, only 1 minute I need. So a real case study is presented, and it is concluded that the blade has been failed due to the combined effect of hot corrosion, oxidation, and high cycle fatigue. And these are the references that I have considered, and thank you for listening so patiently. Now, if you have any query, then please ask.
I would like to request session chairs to please ask questions.
Hello, ma'am. Very nice presentation.
Thank you, sir.
Really, you have done tremendous work on the fatigue and the same images. To congratulate to you for that presentation.
Thank you,
Very nice presentation. I have only one question.
Yeah.
There is a two things are to be there. One is a hot corrosion, one is a vibration problems.
Yeah.
So have you done anything about the root causes of the vibration analysis of the turbine, and how you will measure the turbine vibration?
Sir, actually, I have vibration analyzer in my lab. I am professor in DTU, Mechanical Engineering Department. So with the help of that vibration analyzer, I have done free vibration as well as forced vibration. For performing free vibration, as I have collected this gas turbine blade, I hang it with a string and then hit it only once, and then I record the signal that I have come, and then I analyzed it on vibration analyzer, and I have found the frequency. And the same I have done with computational analysis, and then I compare. I found within a 3% the frequency is same. By that I can say that my experiment is correct. So this is the only way to measure the vibration of turbine blade. There is no equipment as such available which give you the vibration ki how much modal frequency of this equipment, because there is so much noise. It is not acceptable, because if you measure it, then other noise part is also included in it. So only the vibration part, if you want to, you want a very filtered software which is as such not available.
Yeah, that is there. But this vibration analysis only give the FFT analysis.
This will give you the FFT analysis of
and
the,
which will not give the masking and the noise effect on that. So we are not able to find the right cause of the failure
sir,
of the blade.
sir, there is two part.
Right.
One is the metallurgy part, and
Right.
other is the mechanical vibration part.
Right.
For the metallurgical part, we perform SEM.
Right.
And
That is beautiful.
That is one thing. And
Yeah.
for the vibration, as I told you, there is no equipment till now available. So
Okay.
I have used one software which I have collected in my vibration analyzer from AMI Limited. And
Okay.
by that, I have performed free vibration. I have one paper on it, which is presented in Springer, Vibration Analysis of First Stage Gas Turbine Blade. In that paper, I have done all the free vibrations, and I have given you the technique, that is GPRS, how to calculate the mode shape of a turbine blade by using that FFT's result. So there is one technique, global rational progress scheme, ऐसे कुछ करके है sir.
Right.
If you refer that paper, so you will get the technique from FFT, how we will get the modal shapes, and then these modal shape that I have collected from the vibration analysis, I have done computation analysis, and then I have compared these two, and I will get the similar result in that.
Okay. Thank you very much.
Thank you, sir.
Thank you very much.
Thank you, sir. Thank you.
Thank you very much, ma'am, for sharing your reflective knowledge with us.
Thank you, sir.
The next distinguished to honor us with his presence is Miss Priya Singh, on stage for his presentation on a paper titled on modeling and simulation of hydrogen fuel cell and proton exchange membrane fuel cell with e-scooter.
A very good afternoon to all. Firstly, I want to thanks to conference committee for giving me this opportunity to present my research ideas on such a great event. I am here to present my research idea, which is on modeling and simulation of hydrogen and proton exchange membrane fuel cell with e-scooters. This is an innovation which replaced the rechargeable battery in electric vehicle with the fuel cell. First, we move forward to my biography. As I am a BTech student currently pursuing, and my specialization is mechanical engineering. And I'm skilled using in this software, SolveWorks, SCADA, and PLC AutoCAD. My content is introduction, fuel cells technology, why fuel cells only, and many of the contents are written here. In the introduction, as I told, I'm doing an innovation in the electric scooter. As we've seen in a electric scooter, conventional electric scooter, there is a chargeable battery needed, where it needs to charge every day, charge repeatedly. For that time, we need to stand the scooter for the while, and it will waste most of the time. But by the replacing batteries with the hydrogen and proton exchange membrane fuel cells in scooters, the above mentioned issues will be solved. And from these achievements for the developed technology, we must replace conventional e-scooters with the proton exchange membrane fuel cell. Now, this technology, which we are using fuel cell in the electric scooters, which will make it possible to solve all the environmental problems. We are having, as we see in the batteries operated electric scooters, there is a harmful emissions occur. But in the fuel cells, there are no hazardous emission occur, as we made a model for the proton exchange membrane fuel cell in this project. And the most frequent vehicle used for a short distance in our world is e-scooters generally. As we have seen in local typical e-scooters, it's need always to be charged repeatedly, but in fuel cells, it doesn't need to do. In the fuel cell technology, fuel cell has endless amount of fuel supply, but in the battery, there is limit amount of fuels needed. In the easy, peaceful, and ecological responsible energy is possible. And there is scope in the technologies that hydrogen fueling stations should be planted to get clean energy for our environment. There is more hydrogen station to be planted in each areas to get more efficient for this technology. Why we use fuel cell only, not any other component? Because it's because most important, it have no harmful emissions. That was the main motto. And the efficiency for this fuel cell is 70 to 80% with waste warmness utilization. And mostly the size of fuel cells is very small. So it is generally used in power gadgets like computer systems, telephones, and the power supply we get from the fuel cells is many more longer than the conventional batteries. What's the problem associated in the conventional e-scooters? And we are solving this, the proton exchange membrane fuel cell, is the charging issue, which is associated where it needs to keep standing for the charging period. But in PEM fuel cell, in the PEM fuel cell with e-scooter, it only needs to 5 to 10 minutes to refill the hydrogen, and it travels up to the 300 miles and more. Now, fuel cell market, there is opportunities and challenges as well. As we see from the 2022 to 2027, there is a growth in the market about 41.62% as per according to the compound annual growth rate. There is many of the countries which involved in fuel cell markets like China, Japan, South Korea, and India. China has the first one who adopted a strategy to develop electric vehicle with fuel cell for the reduction of pollution. Here is an opportunity. What opportunity we have from the fuel cell market? Opportunity we have now to improve fueling, hydrogen fueling station. And the challenges we have, there is a fuel cell, high fuel prices for the mobile vehicle. Their prices will be high. That's the challenge we face. And now let's talk about the proton exchange membrane fuel cell. That what is proton exchange membrane fuel cell? It is generally an electrolyte member which only allows solution to conduct electricity. There is a thin permeable sheet which allow hydrogen protons to pass through it, and which exhibit the passes of electrons. And it generally act like a sandwich between the anode and the cathode. This is the 3D CAD model of hydrogen PEMFC, which is made on CAD model softwares. Here we the comparison between the rechargeable battery and fuel cell battery. Then what are the difference between them? First, rechargeable battery is a producing device such as electricity, but fuel cell is an energy stored device. Fuel cell never degrade over the time, but it will. But in case of rechargeable battery, it will destroy soon with the time because it can't supply electrical energy for a long time. Fuel cell is the reason for the green energy, but in the rechargeable battery, there is a harmful emission we have seen. There is a picture which shows the difference between fuel cells and batteries. Here is the importance of the proposed project, because as we seen before, the cost of the hydrogen was not so low. In the 2020 year, there is a hydrogen produced with a projected cost of $10 each at a plant gate. Same in the 2020, there is a hydrogen generation technology to produce hydrogen with a project with the renewable photoelectrochemical, where it cost $4.0. But in the upcoming year, 2023, the cost of the hydrogen from biomass, it will reduce due to derived from the renewable liquids. In the upcoming 2024, there is also reduction in the cost of hydrogen from the electrolysis too. What are the benefits from this idea? Simply, hydrogen is inexpensive, so its production in nature compared to petroleum is not that difficult. Because in the petroleum, we can say that it's very difficult to produce, but in the hydrogen, in case of hydrogen, there is not that difficulty we will face. And it's also environment friendly, no hazardous gases emits, as already I told you. And the most important thing, the small size of fuel cell. The small size of fuel cell is the very good reason to implement this in the gadgets like mobile phones and medical equipments using laser and nanotechnology. Here is a conclusion from the project that we will make a CAD model for this system, where we will analyze all the models through ANSYS software, where we are doing finite element analysis. And from the analysis, the planned e-scooters will be more affected when the fuel cells are installed on it compared to chargeable battery. These are the differences which I am written now. Thank you.
Thank you so much, ma'am. It was a spectacular session by you. I would like to request session chairs to raise questions if any has. Any from audience? Okay. Now it's time to cheer the strength of next researcher. For that, I would like to invite Mr. Ali Ahmed to come on board to present his paper titled Reduction of Heat Affected Zone Through Analysis of Different Types of Welding at Different Material. Ali Ahmed, are you there?
Yes, I'm there. Can I start?
Yes, sir.
Good afternoon, everyone. Thank you, everyone, giving me this opportunity to present my paper on reduction of heat affected zone through analysis of different types of welding and different material. Let me share my PPT. So my paper, my PPT on reduction of heat affected zone through analysis of different types of material and different materials. Basically, heat affected zone is the area which, when we started building, the distance between the molten metal to the undisturbed metal, the area is called heat affected zone area. Basically, when we try to break the material, joining material, the joint will occur at heat affected zone. Okay, heat affected zone occur. We can minimize the heat affected zone area, but we cannot neglect, because at the time of building, the temperature is too much high. In any mechanical experiment or other experiment, temperature take place at very high ratio, then the heat affected zone will take place. Now, we concerned about what is heat affected zone and design of heat affected zone. My PPT is visible to you, everyone.
Yes,
See,
yes.
are you seeing melted metal? That if you are doing arc welding, then the melted metal and near the melting line. See this from melting line to last of incomplete transformation of structure area is called heat affected zone. When we try to break the material, it will break from here only. The melted line, transition zone, excessive heat affected zone, also known as coarse grain structure, annealed zone, also known as fine grain structure, incomplete transformation of structure, and base metal. Base metal is also known as undisturbed metal. Any phenomena will take place at heat affected zone. Stress concentration, design of materials will take place at heat affected zone. Now coming to our work, we basically work on mild steels by the arc welding. Here we mention different types of weldings are electric arc welding, gas welding, tungsten inert gas welding, metal inert gas welding. Different materials are mild steel, cast iron, gray cast iron, or other materials can be explained by it. But because of lacks of resources and economic conditions, we didn't perform. Now I'm mentioning that what were the constant and what were the variable throughout the experiment. We took 3 different currents, variable currents at 56 ampere, 128 ampere, 200 ampere, and our voltage, thickness of materials, dimension 100 centimeter length, 40 centimeter 100 mm length, 40 mm width, and 5 mm thickness of materials. We took total 18 pieces and 9 pairs. I will show you later. This is the workpiece. Total workpiece is 9. This is the current variable, and after the building, we took materials on HZ heat on UTM, universal testing machine. Here we get stress, strain, loads, elongations, factors. See, this is the stress machine where we get the stress, strain, and elongations, and see the results not, and we get the graph of workpiece 1, 2, 3 of every material have different graphs. In today welding operations, which is going in our market, much of welders are not aware about welding specification. Means many of welders don't know how to weld proper, how to design it, what material, how much material we should pour on welded, how much material we should weld, and the welder weld the material according to experience. Generally in market, welder weld the material according to experience. They don't have exact data, and our work is on exact data. We work on exact data. I will show you result. And generally in our market, chances of blow of holes creation or failure of metal is more because of lack of data. In our market, data is not available in any outlets. So the workers not weld proper, and the losses are more. Now the basic of our research and motto of our research to save our metals, which is very costly in today's lives. Okay, before COVID and Ukraine war, the inflation rate of every metal was 6%. But I'm showing to you after the COVID and Ukraine war, the metal rates high. Zinc $1.1800 per dollar after the COVID in 2022 for 4,500 rupees ton. See, you can visible the inflation rate. Copper 4,800 tons, not 10,800 tons. Aluminium 800 tons, 3,300 tons, and the nickel 12,000 tons, now 34,000 tons. Lead 1,000 tons, now 2,400 tons. This is the inflation rate now. So basic our motto is to preserve material by giving a precise data. This in result you are visible. My result is visible to you. This is our data. We conclude this data from lots of 9 experiments. For each current The current is we took three different currents, 56 amperes, 128 amperes, and 200 amperes. For 56 ampere, we done three experiments. We took out of this one precise data, and the workpiece number, welding rod, and we took two different welding rod because 12 number and 10 number. For 12 number, 25 ampere current, timing of welding parts is 32.07. Stress created 25 into 0.8. Strain is 24.5 into 0.8, and load in kilonewton 25 into 0.8, and elongation and mm5. This data took from three experiments, and for 128 ampere current, welding rod number is 10, and the timing of welded parts 14.90. Stress is 29 into 0.8. Strain is 5 into 0.8. Load in kilonewton 27 into 0.8, and elongation is 6 mm. For 200 ampere current, in this current 200 ampere, the welding is fine because of high ampere currents, and the same voltage is same throughout the whole process. The workpiece welding rod number is 10, and the timing, you can visible from here, timing is less because the high ampere current 9.51 seconds, and the stress is 31 into 0.8. Strain is 3 into 0.8, and load in kilonewton 31 into 0.8, elongation is 7 mm. So my conclusion throughout the experiment, throughout the process, as I mentioned below, that due to COVID and Ukraine war, our international market stops, shut down, raw material cost, inflation rate high. If we use the data, then the chances of the material is to save. If we use data, the material will be saved, and we can use a proper chart format. So by showing a precise value of stress, strain, load, and elongation at different material, at different welding, at different currents, we can preserve our materials. So thank you.
Thank you so much, sir, for your valuable knowledge with us. I would like to request the session chairs to raise questions, if any.
If anyone have any question, then he can ask.
A very nice presentation. Can you give me where your research will work in a welding heat affected zone? What is the application area of your work?
Sir, generally we can use data. We can use data in high laboratory. Generally, in India, our workers are not skilled. He is skilled, but he's not knowledgeable. They will not use. But in precise laboratories, in big laboratories, we can use, because if you used in rocket science, the data will be more valuable.
Okay, thank you very much. Okay.
Thank you, sir.
Now I would like to request Mr. Bikram Kumar Shah to come on to present a paper titled on review of autonomous vehicle development approaches and issues.
A very good afternoon to everyone.
Your voice is breaking. Network issue.
I'm Bikram Kumar Shah. I'm going to present an autonomous vehicle. Audible now? Hello? Hello?
Yes, sir. Now audible.
Okay. So a very good afternoon to everyone. I'm Bikram Kumar Shah, and I'm going to present my presentation on topic autonomous vehicle, review of autonomous vehicle development approaches and its issues. So coming upon the biography, I'm a student of final year degree from Uttarakhand Technical University, RIT, Roorkee, and I have a knowledge of technology, tools, and practices on SolidWorks as well. I have also worked as a team member to accomplish engineering as a personal goal. So coming up on the abstract, autonomous driving is expected to revolutionize road traffics, attenuating current externalities, especially accident and congestion. Vehicle maker researchers and administration have been working on autonomous driving for years, and significant progress has been made also. However, the doubt and challenges to overcome are still huge, and the implementation of a autonomous driving environment encompasses not only complex automotive technologies, but also human behavior, ethics, traffic management strategies. As a result, vehicle makers do not expect to commercially launch fully driverless vehicle in a short terms. For the technical perspective, the direction of obstacle at high speed and long distance is one of the greatest difficulties to face. From the introduction, my co-leader, Mr. Nitesh Khan, will represent you the remaining presentation. So please.
Good afternoon, everyone. I would like to simply continue the presentation. Like we all know, these autonomous vehicles are commonly known to people in today's world as self-driving vehicles, and driverless vehicles are. It is all like self-driving cars are capable of sensing its environment, moving safely with almost zero human. But like we don't need any extra effort. It knows it has its own capability of moving. Like it's not a new thing. This back to a old time. Again, 1939 there was autonomous vehicles concept. The General Motors has also worked on it on 1958. Now, like transportation, but in today's time, like there are many more facilities added, and people now the users also encompass comfort, safety, and convenience in additional transportation. This prompted intensive study of enhancing cars and introducing new and improved technology. Soon after, the concept of making vehicle autonomous was born. Researchers started experimenting with autonomous as heavy research expanded to make cars driverless. Many technologies were being developed and integrated into them. In order to achieve autonomous and security, modern navies are equipped with a variety of sensors, including cameras, radar, lidar, and ultrasonic actuators. They tell the car on things like traffic flow, lane occupancy, and object detection. Radar and lidar sensors are utilized for object recognition and collision avoidance, while camera sensors supplement the field of vision. The algorithms, which are like AI, machine learning, and DL integrated with image processing, and are used to assist an AV in carrying out autonomy-related activities. Like now, there is a question like why there is need of autonomous vehicle in today's time. The research conducted with a strategy and PwC strategy consulting arm shows CAVs have the potential to significantly reduce social exclusion. 71% of the survey respondents aged between 17 and 24 said this new technology would improve their quality of life. Meanwhile, 69% said they feel positive about CAVs, with almost half 49% saying they would get in one day if they could. 71% of young people say connected and autonomous car will improve their lives and give them greater freedom. And new study. Next generation of car buyer leaders CAV charge with half of 17 to 24-year-olds saying they would use self-driving car today. Like we can see a pie chart here. In time, young people's awareness of connected and autonomous technology in vehicles. Like 66% people don't know the electric vehicle, the self-driving cars. 13% people are not aware. Like you can see the pie chart, a very less amount of people know. But now people are getting aware of things, getting aware of the facilities that can be like required in modern world. Now here are some common terms related to autonomous vehicle. You can see here like two-dimensional, three-dimensional, ABS, anti-lock braking system, AI, artificial intelligence, autonomous vehicle, the CCTV, closed circuit television, CNN, convoluted neural networks, DL, deep learning, FD, fault detection, exclusion, GNSS, global navigation satellite system. global positioning system, GPS, inertial navigation system, INS, IoT, Internet of Things, IoV, Internet of Vehicles, ITS, Intelligent Transportation System, radar, light detection and ranging, LSB, lithium sulfur batteries. There are some extra terms like LTE, long-term evolution, machine learning, metal organic frameworks, operational design, domain, object and event detection and response, pedestrian planner, radar position, velocity acceleration, radio detection and ranging, RGB, red, green, and blue, active safety system, monitor and feel the environment both within and outside AVs in order to detect possible and actual risk to passenger. By warning the driver, modifying the vehicle system, and managing the subsystems like the throttle, brake, suspension, etc., it automatically intervenes to reduce likelihood of potential collisions. Now we can see there are some sensors that are used in autonomous vehicles to make it we need a lot of safety measures to make it working, keep it working. Like there are some sensors like visible light cameras are installed in autonomous vehicle to provide them 360-degree view of their surrounding. They are excellent at. Look, am I audible?
Yes, sir.
Addition, like here you can see there is a radar. It is a sensor that measures things like distance, velocity, and angle using radio waves. AVs can generate radio waves from the user radar transmitters and detect reflected waves with the aid of radar receivers. Radar is effective in most weather conditions and at great distance, but it has the potential to identify objects sometimes. The device emit laser beams. There is a lidar. There is GNSS. It provides essential information like navigation, location, and traffic by describing the design and setup of satellites. GNSS measure the distance between the vehicle and satellite in geostationary orbit using triangulation to determine the position of receiver. These signals can, however, be affected by interference because they are like faint. Here is an ultrasonic sensor also used in there is only price for short range parking devices, but it is compulsory in a self-driving car to see the safety of the air. You can see it measures it reflects through a wave. Service is offered without charge to general public and is essential for autonomous vehicle path planning. Next, we see there are some things to be taken care of. There are some perspectives. Here you can see environment perception. Any autonomous vehicle must independently perceive its environment in order to gather the necessary data and make appropriate control decisions. Visual navigation, laser navigation, radar navigation can be used for environmental perception. There is a path planning. This is one of the most difficult processes, and it requires an item to choose the best route between 2 points. Trajectory planning is another name for path planning. Based on onboard sensors like lidar, camera, GPS, millimeter wave radar, sensors, etc. we used to give the vehicle an optimal path in real time. Now we see about vehicle security. There is in autonomous driving, it is a big development trend that the automotive industry is now experiencing. As a result, components like sensor, communication system, actuators, etc. are starting to appear increasingly frequently in cars. The variety of methods that cyber attacks might happen has expanded as a result of this, which has raised complexity. So, to overcome this fault, there is a security systems are being developed. Different programs are being developed in today's world to overcome the hacking problems. Then there is a motion control, motion planning algorithm choose routes for certain scenarios. Such algorithms must also be taught the driving habits of the nearby vehicles. It is put into practice by giving the AV safe motion by controlling steering and accelerating appropriately. Like artificial potential field, sampling based techniques, and optimal control techniques are the 3 key categories.
Sorry to interrupt, your time has been exceeded. So please conclude.
Okay, sir. Okay, thank you. I will like I'll tell you the advantages of heavy and like all over it. Its most advantage is technology is eco-friendly, drastic reduction in road accidents, reduction in traffic congestion, more accessible to many people and many more. Like there are some disadvantages too. Its cost is high, huge skill manpower is required to maintain the technology. Technology taking over our vehicle means it can take over our privacy, and dependency of technology means vehicle may be prone to hackers too. Okay, so that was all for today. I would like to.
Thank you. If there anyone having query about his presentation, they can ask to him.
Are you audible? Yes, there is a two question from you.
Yes, sir.
This is a CAD on SolidWorks or ANSYS model. Can you make it in a real manufacturing in this India?
So actually, like we are working on its CAD model, and the sensors that are generally used in it are generally a little bit more costlier. So like we are like type of finding some kind of outsource. Like if there is available any like funding option available, then we will successfully like able to like manufacture it.
Okay, thank you very much. Yeah.
Thank you, sir.
Thank you for presentation. Now it's time to encourage the spirit of next researcher. For that, I would like to invite on board Mr. Vedant Ajay Utikar to present a paper titled on ADAS, a modern technology in automobile sector.
So good afternoon to one and all present here. My name is Vedant Utikar, and I would be giving a brief overview on ADAS system used in high-end automobiles as of now. And recently, Mahindra has been using it in their XUV 700. Biography of myself. My name is Vedant Utikar. I am a UG student. Department is Mechanical Engineering, and college is JSPM Rajeshri Shahu College of Engineering, Kathode, Pune. The co-author of this paper is my mother, Mrs. R.T. Ajay Utikar, Assistant Professor, Instrumentation and Control Engineering, Dr. D.Y. Patil College of Engineering, Apurdi, Pune. Next one, the abstract of my project. Human mistakes cause maximum accident, as we have know. To minimize those accidents, we can use the ADAS system. The role of this system is to reduce the number of the accident and the gravity of those that cannot be prevented in order to decrease the mortality and injury rates. Because of driver error causes road accident, ADAS is meant to automate, respond, and upgrade the car technology for a greater safety and driving. Pedestrian and video detection for advanced driver assistance system, that is ADAS, has emerged as a hot technology issue of interest to the government, OEM manufacturers, suppliers, universities, and research institutes. Vehicle hardware in loop, that is VEHIL simulation, is based on is used to test and develop sophisticated driver assistance system, that is ADAS. So what is ADAS? ADAS is advanced driver assistance system, is a group of technology, electronic technology that assists the drivers in driving as well as parking functions through a safe human machine interface, that is HMI. ADAS increases car and road safety. It uses automated technologies such as sensors, cameras to detect nearby obstacles or driver errors to respond accordingly. ADAS can enable various levels of automation in autonomous driving depending on the feature installed in the car. Next, the components of ADAS are sensors, software and mapping system, actuators, and processors. Here is an image of the thing, how they work with each other. First of all, sensors. Sensors are used to ensure the adequate safety measure taken based on the specific situation. However, no one sensor can guarantee safety on its own. Hence, there are various sensors which work hand in hand and give various levels of ADAS. The standard sensor suite comprises of ultrasound sensors, LiDARs, radars, radar technology, and visible cameras. Software and mapping system. Software is considered as the backbone of hardware functions. Today, with changing customers' experience, almost every automotive company relies as much as on software it does on actual vehicle. ADAS system are becoming more effective and seeing it an increased option with use of digitalization technologies such as cloud computing, mobility, deep learning, and artificial intelligence. The next one is the mapping system. The geographical and infrastructure information is gathered, stored, and updated via sensors to govern the vehicle's exact location. This information is maintained and communicated to the control system, even if the GPS fails. Next are the actuators. The electrification of the actuation system in vehicle has a major facilitator of ADAS. This allows various ADAS systems to function smoothly with other electrical components in vehicle. The processors are able to analyze the data from the vehicle sensor, and the ADAS system can make resulting decision achievable by the actuators. Next are the processors. In ADAS application, processors are used for everything from building a real-time 3D spectacle model of a car surrounding to computing proximity and treat level based on the environment. Due to the length of qualification processes in automotive industry, the adaptation of advanced manufacturing technology is almost 6 years slower than the rate of average smartphone processors adapted. Next one is the block diagram of ADAS system. Here you can see the smart sensor, which communicates, which has a sensor communication protocol that communicates with the sensor processor along with the RAM and ROM. The communication portal then then communicates with the centralized processor to give you the idea of clock speed, power required for the vehicle, and that is the communication portal, and that communicates with the smart actuator. The whole thing working together hand in hand makes an ADAS level 1 system. Going to the applications of ADAS system, here is a image showing the application, starting from night vision surround view camera, front view camera system, interior camera, driver monitoring system, side impact assist, radar function center, high beam control, cross traffic assist, etc. To conclude the presentation, this describes two issues encountered in the research data, that the lack of first one is lack of public guidelines, and the second one is trouble in reproducing many of the intended ways. The purpose of driver assistance system is to reduce the number of accidents and injury. However, vehicle in loop simulates the development and validation of driver assistance system. ADAS performance and reliability are tested with high accuracy and reliability in this controlled environment. It reduces number of loops in your development process, saving you time and money. Within an adaptive control system, typically two short-range radar sensors are used to detect objects alongside ranges, and long-range radars are used to detect objects in the path. 3 sensors may be required for this. Even we can use more sensors to get more enhanced safety. Introducing IMUs and GPS technologies can help improve LiDAR and radar ranging. Thank you. If anyone has question, they can ask.
Yeah, there is 2 questions. Your ADAS technology really very good and very nice presentation. Can we use this technology to our old vehicles?
Yes, sir. We can use this technology in our old vehicles as well. Just we need the required sensors and the required canvas communication, which comes with the communication portal in between the steering wheel, the engine, and the various sensors and the cameras present.
I have an old Sandro, which is outdated of the market, but due to the 15-year permission in my country, I am running. If I want to install in my vehicle, how much the cost will come from your ADAS system?
For implementing ADAS system in old vehicles, not old, but old generation vehicles, you can say. It might cost us around 75,000 to 1 lakh rupees, depending on the level of ADAS you require. Like there are 5 levels of ADAS system, in which it starts from level 0. In this, you just get the cameras and you get the parking sensors, which is now basically a requirement for each and every new generation vehicle. The next level comes with 360-degree cameras and blind spot detection. The next level comes with the radar system, in which long distance objects can be detected from a 500 meter of range. And similarly, increasing the levels, you get the increased safety. And the last level, that is the level 4, it can be considered as a autonomous vehicle.
Okay, thank you very much. Very nice.
Thank you, sir. Thank you, sir. Thank you.
Thank you very much, sir, for sharing your reflective knowledge with us. The next distinguished to honor us with his presence is Mr. Abhijit Kumar Bhagat for his presentation on a paper titled Industrial Automation is Facilitating with Product Quality and Makes It Reliable, a review. Abhijit, you are not audible.
Good afternoon, respected all present here. First of all, I would like to thank all my respected for giving me this golden opportunity. My name is Abhijit Kumar. I am here to present my presentation on industrial automation, which is facilitating with product quality and makes it reliable. It is a review paper. My guide name is Dr. Madhvendra Saxena. The contents in my presentations are biography, introduction, proposed architecture, block diagram, hardware implementations, advantages of system, disadvantages system, conclusion, and last is the appendix. And this is my biography. As I have told, I am a student of BTech Mechanical Engineering second year. I have a knowledge of mechanical design using AutoCAD, engineering drawing, and I am also a freelancer. This is the introduction of my topic. As industrial automation is a boon for the industry, means industry will be running through internet. Many various scientific methods and techniques were we were using in the past to run the industry, which were mechanical, hydraulic, electrical, electronics, pneumatic, computer-based, and to automate the processes in the industry. This is the proposed architecture. Here we can see in this architecture starting from level 0, level 1, level 2, level 3, and level 4. In this level 0, there are sensors and actuators. A man with a website having a login ID and password will log into the website, and then the sensors will get activated and will be sending signals to the PLC. And the PLC is the programmable logical controller. Here, the PLC is the main industry. We can say that PLC is a industrial-based computer which is adapted for the manufacturing process in the industry. In the level 2, there is a SCADA. SCADA is a type of system used in the industry, in the private and public sector to control and maintain the efficiency and distribute data. In the level 3, there is a MES, which is a manufacturing executing system. which is designed, which is a software to design to optimize the manufacturing process by monitoring and tracking, and to observe the quality of the product and reduce the inventory cost. And in the level 4, there is a ERP, which is the enterprise resource planning. It is the being in charge of the business process by software and technology, and automate the daily working of the machines and equipment in the industry. This is the block diagram. In our daily lives, we are using many sensors, but here in this block diagram, we are having 3 sensors: IR sensor, air quality sensor, and a temperature sensor. The IR sensor is an infrared sensor, which is typically a light spectrum. It is a transmitter from which we can send signals through a wireless communication. And next is the air quality sensor, which is used to monitor the quality of the air in a surrounding, in our outdoor and indoor. It also detects the air pollution. In a temperature sensor is a sensor in which we use in our daily lives, in a refrigerators, thermometers. So the sensor is a sensor used to detect the hotness and coldness of the machines, and it also sends signals to the main person who is sitting somewhere to control all this. By these 3 sensors produce 4 parameters, which is these 4 parameters are being uploaded to the IoT server by the Wi-Fi module that we are using. This is the hardware implementations that are being used in the systems, starting with the infrared module, DHT22 sensor, switches, ESP8266 Wi-Fi module, motor driver, and last is the Arduino. This is the infrared module. Here we can see in this picture, there are 2 LEDs present here. The white LED is a transmitter, which receives, which transmits the signals, and the black LED is the photodiode, which receives the signal. The IR sensor, it is used for the goods detections and the counting of the products being loaded in an industry. And the next, this is the DHT22 sensor. It is basically a temperature humidity sensor, which is used for measuring the temperature and humidity of the products and the machines. It is simple to operate. It is small in size, and its distance transmission distance of approx 20 meters. This is a switch. Everyone know what is a switch. A switch is a device which is basically responsible for the to start and stop the current flowing through a circuit. This is the ESP8266 Wi-Fi module, which is basically responsible for the whole system. This Wi-Fi module will connect all the other systems to the internet, and sharing all the informations through a IoT server. This is the motor driver. It is a typically type of motor driver we are using here is the ICL293D IC, which is responsible for to drive the motors in either direction. The motors can be of big and small both in size. And this is the Arduino UNO. It helps in interfacing all the component, and it can be programmed by a environment called IDE, which is the integrated deployment environment. It can be programmed and can be functioned in many industries through an embedded system to automate the whole industry. The 2 languages that we use in that we can use in this are the C and C++. These are the advantages of my systems. It can cost effective, convenient method for monitoring from anywhere. It can reduce the accidental cases in the industry. It can push industries to a new era. Through the system, whole industry will be digitalized. And some disadvantages of the systems are it takes a delay of 10 seconds to upload the whole data from the industry to a server. And the second point is it cannot perform complicated or non-respective tasks. It has a high initial cost and require maintenance and training. And this is the conclusion. As we know, earlier the industries were watched by the cameras, but we have deployed a at Internet thing in an industry to eliminate the manual overhead, because this process occasionally run late and cause damage to both property and people. For detecting the bottle size and counting the number of bottles, a simple conveyor belt mechanism is employed in the system. Furthermore, this system allows us flexibility for computer side and conveyor belt control. And last, this is the appendix from I've taken help, and thank you.
Thank you, Vijit, for your presentation. I would like to request session chairs to raise questions.
Abhishek, very nice presentation.
Thank you, sir.
Congratulate to you. Have you done any prototyping work on and data collection from your hardware and the temperature?
Yes, sir. From my research and some data I've collected, in that I've seen the sensors that we are using send signals and to the PLCs, and the PLC then send signals to the SCADA. Then the SCADA is a system through which the DES is operated, and then the whole system gathers the values and the information, and then it is uploaded to the IoT server.
No, okay, that the data you have collected, that you have to show some analysis on your temperature data. Have you done anything?
No, sir, that I have not shown in this, but
Okay.
I have had. Yes, sir.
Okay, this is a very nice presentation, but next you can do some analysis and result on your presentation.
Okay, sir.
Thank you very much. Thank you.
Thank you, sir. Thank you, sir.
Thank you. Now I would like to invite Mr. M. Mohan Jagdish Kumar on board to present a paper titled on thermal management of lithium-ion battery module with different fan positions.
Yeah. Good afternoon, everyone. Am I audible?
Yes, sir, you can start.
Yeah, am I audible?
Yes, sir, you are audible.
Yeah. Thank you. Myself, Dr. Mohan Jagdish Kumar. Presently, I am working as Associate Professor in the Department of Mechanical Engineering, Gayatri Vidya Parishad College of Engineering, Autonomous, Visakhapatnam, Andhra Pradesh. So here is my brief biography. So actually, in this presentation, we are presenting the numerical simulation of electric vehicle battery by using ANSYS Fluent. We considered 24 batteries which are placed in a single row as a stack, and there are 5 different inlet and exit positions are tested for finding out the velocity, pressure, and temperature distribution. So we named those 5 configurations as type 1, 2, 3, 4, and 5. And the parameters like velocity of the air, the geometrical position of the inlet and exit sections, the amount of heat generation within each battery are considered as boundary conditions. And of course, every one of us knows that electric vehicle battery, EV batteries, particularly lithium-ion batteries, are getting more popular day to day because of their simplicity and lightweight, high energy density, and quick ability to recharge. So, because of those advantages, nowadays lithium-ion batteries are becoming more popular. But the problem is the high energy density, which is concentrated within a small volume and surface area, makes their working function deteriorate with respect to time. So until unless if you are not able to maintain lower working temperatures, their function is going to fail. within a shorter period of time. So that's why thermal management of this EV lithium-ion batteries is very much important. And in this particular presentation, we are going to discuss a simple method of evaluation of the thermal management of this lithium-ion electric vehicle battery. So here is the configuration what we selected. There are 24 lithium-ion batteries placed in one row as a stack. And here you can see there are 5 different configurations of inlet and exit sections. So in the first figure, you can see the air inlet and exit are perpendicular to the stack direction. In the first figure, they are opposite with each other, and in the second direction, they are in the same plane. And the third configuration, the inlet and exit sections are placed parallel to the battery stack. And the fourth one is also very similar. And in the fifth one, the inlet and exit positions are placed as shown in this figure. Now, before moving to the fluent analysis, the grid has to be generated. So we conducted a grid convergence test by changing the number of divisions along the length of the battery stack from 25 to 175. And when the number of elements along the battery is around 150, the grid is converged. And hence, we selected this 150 number as the optimum number of grid size along the length of the battery for further analysis. So here, with those number of elements, we created grids for all the 5 different configurations of inlet and exit positions. And those are shown in this figure: 3.A, 3B, 3C, 3B, 3D, and 3E. And once the simulation run, the results have been plotted considering a reference plane at the midsection of the battery stack as shown in this figure. And all the temperature, velocity, and pressure diagrams are mapped with reference to this we are showing one by one the temperature contours for all the 5 different configurations. For type 1, this is the temperature variations within the battery. For type 2, it is shown in figure 5B. And type 3, it is in figure 5C. Similarly, for type 4 and type 5, the temperature variations within the battery stacks are shown in figure 5E. Similarly, the velocity variations are shown respectively in figure 6A to 6E for different configurations of inlet and exit sections. So these are the figures for velocity distributions and continuation. And here is the velocity distribution for type 5 type of configuration. Similarly, the pressure variations are also obtained, and they are shown in figure 7, figure 7A to E for all different type of configuration under considerations. And the streamlines of velocity also plotted on the same reference midplane, and they are shown in figure 8 A to E for all the different types of inlet and exit section under consideration. So at the end of the simulation, the results are plotted in given in this particular table for comparison between all the 5 different types of configurations. So here the outlet temperature is shown in the first column. Then the average temperature of the batteries is shown in the 4th column. And similarly, the pressure difference across the battery stack is shown in the next column. The average surface heat transfer coefficient the average surface Nusselt number, and average skin friction coefficient. So based on these values, finally what we concluded is, particularly when you consider type 2 and type 3, that means when the inlet and exit sections are parallel to the battery stack and placed top and bottom, we are getting a lower average temperature of the battery with less pressure difference across the stack and having maximum heat transfer coefficient. So with this, what we are concluding is type 3 type of configuration of inlet and exit sections were found to be good in terms of heat transfer coefficient because it is at an around 5.9 percentage higher than the remaining configurations, and the surface temperature is around 2.72 percentage lower than the remaining configurations. Similarly, type 2 configuration is found to be good in terms of pressure drop, which is around 66.51 percentage lower than the remaining configuration. So this is a very simple analysis to know how the batteries should be placed in the electric vehicles, and the analysis will be further extended by implementing more number of rows in the battery region. So here we just consider only one row. So multiple number of rows are generally used in practical applications, and finally we are trying to find out the best configuration of placing the battery as well. So in this presentation only we presented what should be the position of the fans at inlet and exit sections, and which will be the optimum placing of the fan at the inlet section. But further analysis will be done on multiple number of battery stacks, as well as this shape of the battery placing also we are going to analyze it. So that is all from our side. Thank you one and all for giving me this opportunity. And if you have any queries, please ask. Thank you, sir.
Sir, very nice presentation. Thank you very much and congratulate to you. Very nice presentation on the answers you have to do. So can you tell me, when you are implementing in an automobile, what is the two biggest challenges to us?
Yeah, that's what one thing is, the energy density is enormous as the vehicle is running for longer time. So you need to optimize the thermal conditions within the battery, because they are going to get very high temperatures within less operating period. So the challenge is where exactly you have to place the battery, and how the cooling effect could be properly provided in order to maintain lower operating temperatures for these type of vehicles. That is the biggest challenge for these electrical vehicles, and at the same time the durability of the batteries. Again, the
Yes,
companies are looking. The
Yes,
companies
yes.
are looking for the durability of the batteries.
Yes.
Yeah, they want to manufacture at less cost, but they should run for more time. That is their challenge.
Thank you very much. Thank you.
Yeah, welcome, sir.
Thank you, sir, for your valuable knowledge with us. Now I would like to invite Mr. Amyodas, whose paper is present on emerging trends in soft robotics, a review. Mr. Amyodas.
Thank you, sir. Am I audible to everyone? So,
yes, sir.
So a very good morning to the respected sir. We group 4 students are very pleased to present a presentation on the topic emerging trends in soft robotics.
Sir, your presentation is not visible.
So, is it visible?
No, sir.
Now is it visible?
No, not now. Please share the screen.
स्क्रीन शेयर बनाएंगे তো কি আমার বাড়ি আইছে না না এটা করব বাড়ি আইছে হ্যাঁ শেয়ার বানাই নিচে নিচে
Is it share now? Hello.
No, it's not sharing. You can close and try again.
share okay.
Yes, now it's sharing.
Yes. So let me start again from the first. A very good morning to my respected sirs and ma'am. We group 4 students are very pleased to present a presentation on the topic of emerging trends in soft robotics, a review. Myself, Omiodas, pursuing an undergraduate specialization in mechanical engineering in second year from Roorkee Institute of Technology, and I am skilled in using CNC programming, basic AutoCAD, and industrial application on hydraulic and pneumatic. So this project is basically based on the soft robot. So we are going to present a new upcoming topic which can change the view of robot, that is soft robot. A soft robot is basically a robot which is soft and as efficient as rigid robot, and which is less harmful than the traditional rigid robot which are made of steel, aluminum, cast iron, etc. So our motto is to make a robot which is environmentally friendly as well as useful too. So in this presentation we are going to present an content of introduction, types of a soft robot from which we can understand the variety of the soft robot, comparison of a soft robot from which we can compare between the soft robot and traditional rigid robot, and then the fabrication of pneumatically actuated soft robotics from which we can understand how to build a soft robot, advantages, limitation, and remedies of a soft robot, literature survey, conclusion, and lastly the appendixes. So let us start our topic with introduction. So soft robotics are generally made of naturally malleable material which would make the soft robot highly compressive and tensile stress resistance robot. In second point is said that the next generation of the robot will be elastically soft and have the ability to interact with the pupil like a pet. So in the third point, a robot made of soft material is capable of working at any temperature at any place. So a soft robot is maneuverable and elastically bendable so that it can fit the small spaces. The next topic will be discussed by my friend Dipankar De, that is the types of the soft robot. Thank you.
Good afternoon to everyone. On continuing with Omio, let me discuss the types of soft robot. So the types of soft robot are robotic muscles, climbing robots, wearable robots, and prosthetic robots. So the robotic muscles are basically the muscles being produced using a variety of soft robot kinds. It folds up construction in scalable from a few millimeters to meter long and can lift 1000 times of its weight. That's pretty impressive, right? Now let us see the climbing robots. The climbing robots are the type of robots that are flexible and are caterpillar-like shaped that can climb structures. Continuing this, we have wearable robots. The biometric devices can be applied to a patient undergoing physical rehabilitation. The soft robot mimics the natural movement of the body wherever it is placed, helping the patient restore normal motor functions. Now let us move to the prosthetic robot. Superior prosthetic limbs and
extremities can be used using soft robot technology. In order to grab items more precisely and delicately, grippers at the end of prosthetic arms frequently employ soft robotics technology. So these were the types of soft robotics. Now the next topic will be discussed by my co-author Akash Jyoti Gogoi.
A warm good afternoon to everyone. Now let us see the comparison between the soft robots and the traditional rigid robots. The material used in the soft robots are very flexible, soft, stretchable, whereas the material used in technical robots, traditional robots are rigid and hard. The soft robots, according to the conditions of the environment, while we need to give instructions to the traditional rigid robots, the soft robots are very easy to interact with the humans, while it is quite dangerous to get close to the robots operating under specific command for a specific job. The robots are inspired by surrounding environment, which are climbing, holding, etc. While soft robots are unable to work in uneven and unreachable places. In the next slide, we will see the fabrication process of actuated soft robots. Firstly, we have to make a mold using a 3D printer in which we use nylon as our working material. Then we design the soft robot with the help of different CAD software to know the gripping of the material. After the design is completed, we pour the molding material, which is silicone, on the mold and close it. After some time, it would solidify and soft robot is created. The next step is testing, where the gripping capacity of the robot will be developed by passing the air through the pipe into the product with the help of a compressor. The next topic will be discussed by my co-author Tapas Momik.
Let us see the advantages and limitations of a soft robotics. The advantages are stiff against elastic and soft malleable, flexible form, can be produced complicated motion, wide application, collision avoidance via observing impact. And limitations are weaker and less accurate than rigid robots, high complex system, not fixed to structure complexity, trouble controlling higher order system. After this, let's proceed to the remedies of a soft robotics. A knowledgeable individual with an understanding of a pneumatic and compressor may operate the soft robots easily. Soft robots made of a high quality material are going to be needed. Thus, boost the strength of the soft robots. A high power compressor with a exceptional compressive and tensile strength would be needed. The next topic will be discussed by my groupmate Omyo Das.
Thank you for the presentation of my groupmate. So I start with the topic of literature survey. The literature survey is the survey in which we survey the various scientists and the engineers which they have created a soft robot to present this in a journal and in the year. So they have done a hard work from which we get motivated, and we have done this project for them only. So let us go to the conclusion. In this project, we highlight that we spot a new technologies and adapt it and build a future together in which robot will not be harmful and can interact with people just like an animal, and it can be used in manufacturing company as well as biomedical field, in which the use of soft thing is been increasing day by day. So the use of soft robot is rapidly increased. That's being to my end of the sessions and the presentation, and I sincerely appreciate that we had the chance to present this. Thank you.
Thank you for your presentation. I would like to request session chairs to raise questions, if any.
Congratulations for very nice presentation.
Thank you, sir.
my question is that can we develop soft robotics in your lab?
Yes, sir. Yes, sir. Yes, sir. We can develop the soft robot in our lab, but we required a working fluid such as silicons and 3D, and we required a device that is 3D printer, which create a mold from which we can create the structure of the soft robot that we are used to meet.
Okay, thank you very much. Thank you.
Thank you, sir. Thank you, sir.
Thank you. Now I would like to request Mr. Sukhdev S. Vasekar is which on board to present a paper titled on optimized design of shell and tube heat exchanger with segmental baffles.
Hello, good afternoon. Am I audible?
Yes, sir, you are audible.
Is it PPT visible? Hello? Hello?
Yes, sir, visible, sir.
Good afternoon to all of you. I am Professor Sukhdev Vasekar. My short biography is I am working as assistant professor in Sinhagad Academy of Engineering, Pune. And currently I am doing the work on the PhD topic, that is heat exchanger design related things. My guide is Dr. Sandeep S. Kore. And with respect to the topic, that is, I have initiated the work related to the optimized design of cell and tube heat exchanger with segmental baffles. So main motto of the design and optimization is related to the heat transfer and effectiveness of the heat exchangers. So if you go majorly in different types of industrial sectors, so the heat transfer is the major phenomenon where maximum heat exchange is transferred by using the indirect contact type, and that types of heat exchangers are of shell and tube type of heat exchanger. Near about 60% to 65% types of heat exchangers in chemical industry, fertilizer industry, and heat transfer related industries. So they use the shell and tube type of heat exchangers. So my topic is related to that design and optimization. So I am going to invent new type of baffles related to the shell and tube type of heat exchanger. So initial work I have taken into with respect to the initial maximum heat transfer, which is to be carried by the segmental type of baffle with shell and tube type of heat exchangers. So as per the TEMA standards, there are many types of heat exchangers which are designed and used by the industries. So in this paper, I have presented the segmental baffle type of heat exchanger with respect to the different types of CFD models and designs with varying the number of baffles and the baffle cut, which is needed for the turbulence creation in the number of baffles. So here the CFD analysis and the numerical analysis also done with respect to the Kern's method, which is the initial method, which is generally used for the primary analysis for the design of heat exchanger with heat transfer. So to find out the maximum heat transfer and minimize the pressure drop with respect to the different number of baffles, that is I have taken 6, 8, and 10 number of baffles with the keeping on other parameters constant, and the how much the pressure drop it will significantly give. If you go on increasing the number of baffles, the heat transfer will increase, but at the loss of the pressure, because from one end side of the cell we are transferring the fluid, and another tube side we have another fluid. So shell side to heat transfer is increasing, but at the sake of the loss of pressure drop. So pressure drop means consuming more energy and more power. So we need to optimize this model with respect to. So I have done the design of the baffles with respect to different baffle cuts. So 25% baffle cut, if we take, we will get different Reynolds number and different pattern with respect to 35%, 45%. So three types of baffle cuts are taken for the sake of study and the keeping of the velocity, temperature, and the pressure parameters constant. So as per the optimization, we have done the different model studies, and based on that, the whatever the indirect contact type of we can consider for the parallel flow how much heat transfer, counter flow how much heat transfer, and compare with respect to the optimization by using the LMTD method in the defined by the Kern's method. So generally in TEMA standard, E shell type of heat exchangers are used for the design. So this is the basic parallel flow pattern in the shell and tube heat exchanger, which is having a one side tube inlet for the and shell side inlet and outlet with respect to another side. So based on this analysis done for the 600 mm length of the shell and 20 mm external diameter of the copper tube, and there are different patterns are available as per the TEMA standard. So different tube bundles are attached to with studying, and different types of shell material and the baffle material is to be used to hold the number of tubes inside this shell. So in the shell side, heat transfer and the pressure drop, we need to determine and optimize which configuration is better for the transferring the heat, and which may be used for the particular heat transfer IFERP. So here I have considered the 7 number of copper tubes and the analysis point of view, having the diameter of the 17 mm and 20 mm OD and 600 mm length of the shell and the tubes, as well as the 90 mm steel shell, which is having the outer diameter of 110 mm. So based on this, most commonly used types of segmental baffles are of segmental type, zigzag type, or the different baffle cuts and different baffle facings are there. But if you compare all the researchers which have done this previous studies, they found is the segmental, instead of segmental baffle, helical baffles are giving the more heat transfer compared to the for the same configuration. But to reduce the cost and manufacturing and complexity of the helical baffle and reduce the power consumption in terms of the pressure drop, we need to optimize the segmental type of baffles with respect to the new baffle. So my next research, which is on the inventive baffle, which is a modification of the segmental baffle with respect to new type of a baffle. So this is the initial study that I have carried out with respect to the segmental baffle, which is giving the factors in which measure in configuration which will affect the performance. The first parameter is that baffle cut. Second parameter is that baffle spacing, the distance between the two baffles and the baffle inclination. So generally in segmental type baffle, vertical inclination is used, that is 90 degree, but one can try to tilt that also, but the design becomes somewhat complicated. So initially these two parameters I have varied with respect to the considering one of the tube layout. So here the triangular, or depending upon the number of tubes and tube bundles which are to be found out from the TEMA standards as per the tube length and related heat transfer requirement. So the different layouts are there. So with these layouts, the design of the cell and tube heat exchanger, considering, so initially design is done by the segmental types of baffles with 25% baffle cut and theoretical analysis done, considering the 6 number of baffles, 8 number of baffles, and 10 number of baffles. So with boundary conditions and the effect of the baffle on the heat transfer and the pressure drop is to be calculated and studied by using the Kern's formulas, which are used by taking the some initial conditions of the tube side material and shell side material, as well as the flow of the fluid, which generally I have considered here the water as a fluid, having the temperature of 10 degrees Celsius for the tube side, 10 degree, 10 degrees for the cell side degree, and for tube temperature is near about 90 degrees Celsius. So with that temperature of the water, considering the properties of all for cell side and the different flow rates with respect to that flow rate, remaining all the dynamic properties required for the material and the Prandtl numbers for the temperatures are to be calculated, and by putting that parameters in the thermal analysis for the in the CFD metal. So we have done the analysis for the 6 number of baffles, 8 number of baffles, and 10 number of baffles for initially 25% baffle cut. So what will happen to this? So we observe that if you go on increasing the number of baffles, so the distance between these is to be decreased. There is initially 6 number of baffles are shown here. So if you increase 6 to 8, so you will get increase in the overall heat transfer coefficient with respect to 6 to 8 and 8 to 10. At the same time, we will get the heat transfer also increased from 4,700 to 60 to 4,800 and 4,900 watts. And at the same time, we are also increasing the pressure drop. So this pressure drop should be minimized, and we get for the same capacity or same requirement of the heat transfer with minimum power and the less pressure drop and the less cost of operation. So we have to optimize the baffle cut. So then we have done for the analysis on the CFD with respect to the in changing the baffle cut from 25% to 35%. So we get the change in terms of the pressure drop with number of baffles like this. Increasing, if we are going on increasing number of baffles, pressure drop increases. So for the this is the for the first case. So for 3 different cases, that is 25 degree, 35 degree, and percentage, 25% baffle cut, 35% baffle cut, and 45% means maximum baffle cut if you keep on the cell side. So we will get the change in the heat transfer rate and change in the pressure drop. Accordingly, keeping same parameters for the same flow rates, we will get the different conditions, and from that conditions we can optimize which type of the baffle for which type of percentage of baffle we will get maximum heat transfer. So here we have done the analysis. So with respect to the shell and tube heat transfer, considering the 25% baffle cut, 35% baffle cut, and 45% baffle cut. So there is a related things in terms of the transferring the heat transfer from the tube side to the cell side with respect to the change. So if you observe, initially the heat transfer is 3,200 and 23, and then it will go on near about somewhat increase, and then again it will for 45% it will go on decreasing. So this will decrease because for the number of baffles. Reason is that because of the more baffle cut will give you the more place to flow the fluid, and it will not get the turbulence inside the shell side. So if turbulence is reduced, there is sudden reduction in the baffle heat transfer rate, but we will get the less pressure drop, but it should be optimized. So considering all these conditions and parameters, various types of the models are developed with respect to CFD, and then we have analyzed. So 45% baffle cut with 10 number of baffles, we will get the optimized result for the particular heat transfer rate. So considering that, I am going to design the new type of the heat exchanger with respect to the flow divided type of baffles, which will be
Sorry
new.
to interrupt you, sir, but the time has
So
been.
from the conclusion point, last point of this is we can determine the optimization, we can determine the cost and the design complexity based on the helical to the segmental baffle, and we will get the good results for the actual design. So I have designed the actual shell and tube heat exchanger for the next study point of view. So thank you very much.
Thank you so much, sir, for your valuable.
Thank you, sir. Congratulate for your very nice presentation, sir. Sir, I have one question. You have taken water as one fluid. Have you tried another fluid for your
heat exchanger?
Right now, I have not studied, but I have decided after the final design, I have designed and manufactured the cell into heat exchanger. So what we are going to do is we are going to try nanofluid with water mixing.
Yes.
In a non-Newtonian fluid. So that
Yes.
analysis I am going to do in the last stage of my project.
Okay, you can use the ammonia is also the very good option. If you can try. Thank you very much, sir.
Thank you.
Thank you. Now I would like to request Ms. Dr. Madhvendra Saxena. On board a paper titled on Emerging Trends in Humanoid Robotics and Industry 5.0.
Good afternoon to all. I am Dr. Madhvendra Saxena, going to present emerging trends in humanoid robotics and Industry 5.0. That is a concept paper. That is, I am going to present introduction, humanoid robots, opportunity and challenges, risk, design for cognitive robot research, future robotics and artificial intelligence, significance of technology, benefits, emerging opportunity, conclusion, and the references. What are the humanoid robots? In this era, we are going for the Industry 4.0. But what about the next Industry 5.0? Humans are replacing by the robots. We are talking about the soft robotics and different types of robotics. So what is the next type of a humanoid robots? We have created electronics machines which can be replaced by the human efforts. But when we are talking about the human robots, we are using an artificial intelligence. And we are not talking about when we are taking the lot of algorithms and lot of the things are to be there. But the most important part of the human is to be the consciousness and the emotions. Human has 9 emotions and 42 feelings. Can we develop electronics brain such that which will create emotional robots, that is a cognitions? Can we create a cognitions and an emotion and a consciousness in a robot? Yes, we can. If we can go to the historical perspective of the cognition of the robot, humanoid robot, we can see in our epoch
There is a story about the Ram and Ravan. Ravan has a 10 faces. 9 faces are representing their 9 emotions. So that can be created by the one of the apex called as the Ravan, and we have the significance physical roots are to be there. So, but how we can create an electronic brain within a emotions and the feelings? That is the challenge from the industry 5.0. So there is a techniques called as a Professor Menesky, who is working with the computational things, and the book is called as a Mind and the Society. That is the professor who can make the artificial intelligence generate. He get the image processing, which can be classified between the human and cannet. From that book that inspired me, if we can make our emotions and the feelings in a computational, if we can make our computational, which is a function of that is a qualitative analysis. So there is a lot of challenge for us. There is a chemical equations are to be there. There should be the neural networks are to be there, which is to be the research to the area from the industry 5.0. And the challenges are the system must be aware of an ethical issue that should be taken into the account. Within the industry 4.0 approach, challenges have arisen for the humanoid robots to grow the industrial automation. And that is the future prospect of the labor shortage that can be replaced by us. To do something disturbing, that is the risk. Self-governing weaponry is artificial intelligence, it is automatic to kill. We must, that is what we are talking about. We are creating a one bhasmasura to us. What we are creating that will destroy to us. That is the humanoid robots. It has both of the coins. Service performance of the robots, industrial robots are to be there, that the old people care, where people are giving the services, but without emotions and the consciousness. The old people and the human want some type of empathy that can be given by the robots, not by the human. Human are to be just like a robot to make a money only, and they are working for that. There should be the significance of the technology. A lot of people are doing that work. That is artificially brain, how we can develop the brain artificially, which has to the some of the emotions. The mood sensors, facial expressions, if you can see this today's presentations, a lot of the people are working on that. The benefits are the safety, consistency, perfection, job creation, productivity, and likes and the human beings. This is the market size of the humanoid robots. In the next 10 years, we have to be replaced in a South Asia market is to be the very governing, and the North America market is to be the very governing about this humanoids market, which will serve as a your servant also. So I have to conclude that is a new opportunity to us. We have to take the new challenges for the research, for the emotions and the feelings of the humanoid robots, that is the electronics machine. Thank you very much.
Thank you so much, sir, for your valuable knowledge with us. I would like to request session chairs to raise questions, if any. So this is inform you all to complete your presentation within 8 minutes, and additional time will be given for 2 minutes for question and answer session. Now I would like to request Mr. Krishna Sharma on board to present a paper titled on Hydrogen, a clean and green energy for future.
Am I audible?
Yes, sir.
Good afternoon, everyone present here. Thank you so much for giving me this golden opportunity to represent my review paper in front of you. I am Krishna Sharma from Department of Mechanical Engineering, pursuing BTech degree from Roorkee Institute of Technology. Our topic for today's conference is hydrogen, clean and green fuel for the future. And my co-author will present the paper in front of you from now. Thank you.
Good afternoon to everyone present here. My name is Riya Shrivastava and I am from the Department of Electronics and Communication. And today we will discuss about a hydrogen, a clean and green energy. In this paper, we will share screen.
Share the screen.
Please share your presentation.
Yeah, we are doing this. Hello.
Screen share हो रही है? Hello.
Yes, now it's visible.
Okay. So in this paper, we will discuss about the origin of hydrogen from where it began, its properties, production, pros and cons, and how it can be stored. What is the working of this fuel? And after all this, we will come to a conclusion. Can you please give me a minute? Okay. So this is the era which demands a huge amount of consuming fossil fuels. But with this comes the depletion of ozone layer, pollution, global warming. Such problem needs a stimulation with study and research. And with that, we have come to a solution named hydrogen. I'm sure that we all are familiar with this word, but let us recall it once. Hydrogen is the lightest element. Hydrogen is the lightest element that Hydrogen is the lightest element of all. It has atomic number 1 with an atomic weight of 1.0079. It can be stored at a temperature of minus 252.8 degrees Celsius in liquid form. It should be compressed at 350 to 700 bars. Hydrogen was discovered during a reaction caused on metals by acids, and later it was known as an inflammable air. Again, when it got tested by an Englishman, he tested his hydrogen fuel internal combustion engine and started using it as a fuel for rocket engine. It was named after the term hydrogen. The main motive of this paper is to show that hydrogen can and will be the savior against the fossil fuels, as it emits water vapor which hinder the base of Earth. Hydrogen can be produced by 4 main processes, which are steam forming, coal gasification, electrolysis, and photoelectric. In steam forming and method, methane is heated at a very high temperature and then form its hydrogen, and from it, hydrogen is separated. In the process of coal gasification, pulverized coal with an oxidant is heated at a temperature of 18,000 Celsius, and then after cooling and cleaning process, hydrogen is produced. In the process of electrolysis, electricity is passed through water to separate hydrogen and oxygen. This can also be done by solar hydrogen system, but it will get too expensive. In photoelectric process, light energy is used at the source to split water into oxygen. But after all this, The most difficult part is of storing it. Hydrogen cannot be stored like other fossil fuels, as it can leak very easily, and due to its very low density, it occupies more space. So for that, hydrogen is stored by compressing it at a very high pressure and can be stored in three forms: gas at a very high temperature, liquid under cryogenic temperature, and on surface in the form of solid or liquid material, which can be off or within. It is made of carbon fiber composite material with dome protector having high density polymer liner. It also contains pressure sensor to detect the correct pressure of the compression. Let us see some pros of using hydrogen. It is non-toxic, non-polluting. After burning, it emits warm water vapor, and this warm water vapor is so pure that when in space, astronauts drink that water. If we talk about the efficiency and power, after charging for 30 minutes, it can run up to 30 miles. But in hydrogen, if we only charge it for 3 minutes, it can run for 300 miles. If we compare this with petrol, the RPM of petrol and diesel is approx 7,000, but hydrogen fuel has the RPM of 15,000 to 17,000. It is a renewable, clean and green energy source. Just like the pros, there are always some cons. And one of its major con is of storage. Due to its very low density, high pressure compressive tanks are used to store it. We need to store it under minus 252.8 degree cryogenic temperature, which requires 3 times more energy in comparison with other natural gas and fossil fuels. For now, 48% hydrogen depends upon the natural gas, 30% on coal, and 18% on oil. After analyzing it, we have seen that if we will work on fuel cell, then the specific power till 2030 will be 9,000, and till 2045 will be 1,000. The peak fuel cell will be 67 till 2030, and till 45 it will be 68. According to the cost, the 2030 cost will be 52 kilowatt, and till 2045 it will be 30. If we see the international projects, the most powerful companies like China, Japan, UK, Germany, Europe, and many more are working on this. More than 300 billion projects has been already announced with 350 large-scale manufacturers to work on hydrogen energy and its production. There are 8 hydrogen car companies that are working on hydrogen vehicle named Toyota, Daimler, Motor Hyzon, BMW, River Simple, Hyundai, Nikola, and Hyperson Motors. The earth needs to be healed, and if we see the working of hydrogen, there are 2 types of engine, that is fuel cell system and internal combustion. Fuel cell electric vehicles, also called fuel cell system, works the same as an electric vehicle, as internal combustion system works in 4 processes: intake, compression, ignition, and exhaust, which is an electrochemical process rather than combustion. The earth needs to be healed from global warming and pollution. For this, we have hydrogen as the solution. It is the cure to heal the earth and provide a clean break to the earth. These are references from where we took all the information. Thank you.
Thank you very much for sharing your reflective knowledge with us.
Yeah, I have a 2 question to you. Very nice presentation. Congratulations to both of you.
Thank you.
So it can be replaced by, you can say, the diesel in this. We are using as a fuel as a diesel. Can hydrogen fuel replace the diesel?
It can be replaced by diesel and petrol as well.
Okay. So we can solve the problem of a Delhi pollution by your project.
Yes, sir. We can solve the Delhi pollution thing from our project, because there is no harmful emission. We use hydrogen.
So if we can convert your idea into some prototyping and project, so how much time you will both take to convert it to this hydrogen fuel cell as a product?
I think, sir, we'll take approx 1 to 2 years.
Okay. Thank you. Make a project and submit to us. Right. Thank you very much. Congratulations.
Thank you, sir.
Thank you. Now I would like to request Mr. Lokik Deshmukh to present a paper of a new revolution in the tourism industry with touristry. Mr. Lokik Deshmukh.
Yeah, just a second. Hello, screen is hello.
Yes, sir.
Okay. So, hello everyone. Just a second. Okay. So, hello everyone. My name is Multidisciplinary. I am a co-author of this project. So, basically, our title of our project is Touristry. Basically, it is a website. So, we have okay. Sorry, my actually my camera is not on. Actually, yeah. So, basically, my screen is visible, na? Hello.
Yes.
Okay. So this is a basic website. So we are 5 members in this group, and we have completed this website. So what is Touristry? So Touristry is a website which we have made. By using this, we can help various tourists. We have started it from Pune city, and we have recently extended to Mumbai city also. From this this website, we can overcome the various issues like uh, GPS, daily things which are happening at that place. So basic objective of this project is uh, so due to pandemic, various industries are affected, and similarly tourism industry is also affected. So to promote tourism industry, we have made this project. So we have added various types of images. Also, we have added maps, maps or weather. So these things we have added in this website. So problem statement, as I mentioned, this is paper which we have made on a touristry, various kinds of obstacles and problems from foreigners are face daily happens. So to overcome that, we have made this website. So we have used three languages in this website, like HTML2. Basically, this is a skeleton of our website, and CSS is to design our website, and JavaScript basically used to provide a functionality to our website. So basically, we have use software called Atom. So this is a open source software which is used to edit our code and also implement various things we have edited these languages like HTML, CSS, JavaScript. So to work these languages together, we have used Atom software, and we have in future we are also going to add backend also SQL, PHP, and MySQL also. And eventually we are going to upload it on GitHub and to generate some URL. So this is our basically methodology, and we are almost completed the GPS thing and website, also weather system. So basically, this is the progress which have made, and So applications. So what are the applications? So to develop and implement a tourism management system, propose a solution to the problem it's solving. To provide a tourist with accurate information on tourist attractions to make some more informed decision and develop and implement a credible and user friendly system. Uh, and third is to develop a tourism management system that is web based with accessing the system accessibility, uh, efficiency, timelessness, quality and productivity from the perspective of every individual. So benefit of this website is like it is available 24/7, like, and also it saves various times, money, and physical extortion. And we have also added reviews about like what type of this website also. And like in future we are going to add the reviews of the the person which used our website to visit that place. So the conclusion is that this research paper gives an overview of web impact on tourism. This is also a case study mention about that proves the importance of internet website is promoting tourism. This explains the need of our website touristy. Apart from being a business model, this serves the community. So this project is not just the business-minded startup. This system will solve many problems in tourism management. So the project can be improved even further so that the website functions more appealing and ensures customer satisfaction. The system is found to be successful and meets the needs of the users. So the future scope is like we can also collaborate with companies like Swiggy or Zomato to extend our project. And like various websites are we see like Make My Trip or so these websites like work like that, that sites also. And in future like we are going to extend to various states or various countries also. So these are references which we have taken. And thank you.
Yeah, Mahesh, there is one opportunity for you. We are organizing this conference to the Uttarakhand, and Uttarakhand is a very tourist savvy place. Not in a summer, but in a winter when we are sitting in a 4-degree temperature. Here, and the snowfall is to be there. So if you can collaborate with our institute, that can be the heart of the Roorkee and the Dehradun and Rishikesh, and the food has to be there. So give me the proposal and we can sit and we can collaborate. Yes.
Definitely in future.
Yeah. Thank you very much.
Thank you.
Thank you, Mr. Lokik Deshmukh. Now I would like to request Mr. Himanshu Saxena to present a presentation on recent advancement in material science, a survey. Himanshu, are you there?
Yes, I am there. Hello.
Yes, you are audible. You can start now.
Good evening to all. I am Himanshu Saxena, and my presentation is recent advancement in material science, a survey. This is an introduction. Although carbon fiber has been although carbon fiber has been around this 150 years, it has only been through manufacturing process improvement is the last half century. And the last half century on a century or so, that's its excellent strength to weight ratio has been achieved. Sir Joseph Wilson Swan first created carbon fiber in 1862, used in an early incandescent light bulbs in 7. Carbon fiber filament. He's some of the first. Their high heat tolerance, heated by electricity, their high tolerance made them ideal electrical conductors. In 1958, at the Union Carbide Technical Center in Cleveland, O.H. Roger Bacon accidentally produced the petroleum-based carbon fiber when he tried to measure the triple point of carbon by heating stand of rayon in argon. In the early 1916, Dr. Akio Shindo, the Agency of Industry, Science and Technology in Japan, used polyacrylonitrile pen as his precursor. Pen is synthetic semi-crystalline semi-crystalline organic polymer resin that allowed Shindo to create carbon fiber that the 55% of carbon using a much more than cost-effective production method. Improvement in material science for the manufacturing applications. The growing role of carbon fiber reinforced plastic in autos. Carbon fiber reinforced plastic, not just for race cars, they are already a stable alternative. What is carbon fiber? F1 car of carbon fiber construction, significant weight used in hydrogen fuel tanks, cut weight without compromising safety. Why is carbon fiber used in sports car? The growing role of carbon fiber reinforced plastic in autos, with the goal of reaching a government mandate corporate average fuel economic equivalent of 54.4 miles per gallon by 2025. Automakers continue to seek materials that are both light and strong to use in this manufacturing process. And you see in the graph in 2010 to 2020, light vehicle help improve fuel mileage, and strong ones help keeps passengers suffers. Carbon fiber reinforced plastics are a group of advanced materials that can meet both meet requirements. Carbon fiber reinforced plastic not just for race cars, one limited to the auto racing worlds because of the cost production factor. Carbon fiber not being to show up in the constructions of some mainstream vehicles, a trade that like to continue to break in research experts to make carbon fiber reinforced plastic and other composites cheaper and faster to produce. Then to see in this figure, the alternatively stability ideas. This is a uh, this is a roof on. This is occupied by carbon fiber reinforced plastic. What is carbon fiber? Carbon fiber are graphite fibers about 5 to 10 micrometer in diameter and composed mostly of carbon atom. These properties have made carbon fiber very popular in aerospace, civil engineering, military, motorsports, and other competition sports. To produce a carbon fiber, the carbon atoms are bonded together in crystalline that are make or less aligned parallel to the fibers along axis, as the crystalline alignment gives the fiber a high strength to volume ratio. In the words, it's strong its size. F1 car of carbon fiber construction, CRPF, tennis rackets and golf clubs help transform the way those sports were played, and they also revolutions Formula 1 race cars, making them lighter, stronger stiffness, and with parts more easily molded into different shapes in passenger automobiles. It can be found in components like rear spoiler, hoods and roof, and even internal parts such as dashes and interior trims. Cosmetically, it's have an parts of saving weights, and you can see this area is totally occupied by carbon fiber, and also this is occupied by carbon fiber roof. Significant weight savings. Carbon fiber forged plastic is typically 30 to 50% less lighter than conventional material used in automobile constructions, and thus can help pass on fuel saving to consumer. Overall, plastic and plastic composites account about 50% of the volume of a typical, but only 10% of its weight. Overall, plastic and plastic composites account for about 50% of the volume of a typical vehicle, only 10% of its weight. Several automakers are making on extensive use of carbon fiber reinforced plastic in their future vehicle lineup. The idea is to trim ever pounds of vehicle, and reductions of 10% in weight can lead to increase to up 8% in fuel economy. Carbon fiber used in hydrogen fuel tank. Toyota use carbon fibers reinforced plastic fuel tanks in the development of its fuel cell electric vehicle Mirai that will be available to customers in California. This is a fall. The Mirai is powered by hydrogen, runs about 300 miles on a fuel tank. This Japanese automaker, also called carbon fiber reinforced plastic, assessed in Lexus models with the F Sports packaging, include the GSF sedan and LFA supercars. And you can see this fuel tank, hydrogen fuel tank, and this part is a carbon fiber reinforced seal. Cut weight without compromising safety. Using with the US Department of Energy setting a goal of reducing production cost of carbon fiber by 50%, carbon fiber reinforced plastic fiber to become an even more effective tool in the continuous research.
Your time has been exceeded. Please conclude.
Okay. this is my conclusion, and this is a references. And so thank you for this opportunity. And this is my first international conference. And thank you to all.
Congratulate to Himanshu, you are presenting a future material of that. Can what you are talking can be produced in the reality in your lab or in India? This carbon fiber?
No.
So what is your requirement for that? If you want to produce and if you want to manufacture carbon fiber in your country?
Sir, basically carbon fiber is made
Okay, thank you. Thank you very much. Yeah.
Thank you, Mr. Himanshu.
Okay, thank you.
Now I would like to request Mr. Pankaj Himan to present his presentation on design and optimization of heat ventilation and air conditioning system for analysis of indoor air quality in commercial buildings. Good evening, everyone. My name is Pankaj, currently pursuing BTech degree. My specialization is mechanical engineering. Firstly, I want to thank to conference committee for giving me this opportunity to present my research ideas on such a great event. I'm here to present my research idea, which is on design and optimization of heat, ventilation and air conditioning system for analysis of indoor air quality in commercial buildings. In this work, we will calculate the amount of heat that can be initiated inside the heat healthy buildings for evaluation of indoor air quality. Yeah, as I have already told about my research, which is on HVAC system. Here we show all the facts which we have covered while researching. Here we focuses on the modeling of HVAC system, which is generally for evaluation of inner function of indoor air quality. For accurate design of walls and rooms, we have to represent the heat storage and aware of 4 characteristics of building components. In the indoor air quality, the fourth most thought is health, awareness and comfort of building occupants. For the affection occurs in health and performance of occupants, we must have to analyze the concentration needed to reduce pollutants and thermal conditions. Here is the IAQ standards where guideline is shown the quantity of maximum concentration needed for specific indoor air contaminants. There is a limit value for acceptable indoor air quality for different parameters like carbon dioxide, carbon monoxide, formaldehyde, ozone. Here is the guideline for specific physical parameters, which is generally we have ensure about the parameters like air temperature, relative humidity, air movement. Most important thing is why this indoor air quality occurs. As we know, pollutants are everywhere. That's why inadequate airflow occurs. Also, ventilation rate altered due to these pollutants behavior. From the inadequate control of pollution, we will result to face the issue in IAQ, indoor air quality. Here are components that impact the indoor climate, which is generally a building envelope. In simple, we can say if we make a building completely packed with any source of ventilation, then indoor climate condition disturbed. Stated of HVAC system also affect indoor air quality, outside atmosphere and resident activity, which generally happens daily. Design of healthy buildings. Why we need ventilation in our buildings? Ventilation is very important concept We all must have awareness toward this. It result in modification of building which cost energy and health issue. And while calculating ventilation requirements, comfort is losing ground to health. In this paper, we have elaborated about the importance of indoor air quality. Sometimes IAQ can have a negative impact for a number of reasons. So for the current time, it is possible to research and develop IAQ with HVAC system using both computational and experimental method. This is the limitations of HVAC IAQ system. This is the conclusion. In this paper, we have elaborated about importance of indoor air quality. Sometimes IAQ have negative impact for a number of reasons. So for current time, it is possible to develop IAQ with HVAC system, both computational method and experimental method is effect. This is the appendix where all reference shown through which I got ideas about this research. Thank you. Thanks to all.
Congratulations to Pankaj, very nice presentation. You are talking about the real problem of the HVAC system in commercial building. You are talking about some of the challenges, but the real challenges after you have to work in one commercial building, which is to be polluted by the HVAC. So what type of an instrument you will require to real measurement of the indoor air quality?
So I use the ANSYS, which is CFD, and I use SolidWorks to design the HVAC system.
Okay, thank you very much.
Thank you for the presentation.
अब कितना बचे?
पाँच
नहीं, वो तीन नहीं ले रहे। वो
I would like to request Mr. Parth Tyagi to present on machine health monitoring using vibration analysis. Parth Tyagi, are you there? So I move to next because Mr. Parthagi has not in meeting. Now I would like to request Mr. Amit Kumar Rawat, which present on the social media and entrepreneurship growth. Just wait for a while. His issue with the connectivity. At last, we all are thankful to a great motivator and innovator and all keynote speakers for added brilliance for their session. Thanks a lot to everyone who is present here. That's all. Let's meet tomorrow for the next session. Have a nice day.